What if everything you thought you knew about the universe was only half the story? We often picture the cosmos as a vast, silent, and empty expanse, a cold void where stars blink without purpose and galaxies drift in endless darkness. But what if that picture is fundamentally incomplete? What if, instead of being a lifeless machine, the universe behaves more like a living, breathing organism with rhythms, cycles, and perhaps even a form of consciousness? This isn't just science fiction or philosophical speculation. Cutting-edge discoveries in astronomy, physics, and cosmology are revealing a cosmos that pulses, communicates, grows, and remembers in ways that eerily echo the processes we see in biological life. From the rhythmic expansion of spiral galaxies to the instantaneous connections of quantum entanglement, the universe appears to be far more dynamic, interconnected, and yes, alive than we ever imagined. In this video, we'll explore 35 astonishing phenomena that challenge our traditional understanding of reality. We'll journey from the heartbeats of galaxies and the neural networks of dark matter to the metabolic processes of stars and the digestive functions of black holes. Each of these phenomena on its own invites wonder, but together they form a compelling mosaic, a new story of the cosmos as an integrated, conscious, and vibrantly alive entity. You'll discover how light itself may act as a carrier of cosmic information, how gravitational waves ripple through space-time like a universal heartbeat, and how the universe might not only sustain life but actively seek to create it. This is not about replacing science with mysticism. It's about expanding science to include possibilities as profound as they are beautiful. By the end of our journey, you won't just see the universe differently, you may feel it differently. You'll understand how the boundary between the inorganic and the living is far blurrier than we once believed, and how each of us is not merely living in the universe, but participating within a much larger, sentient whole. So settle in, open your mind, and allow yourself to wonder. What you're about to explore may forever change how you see the cosmos and your place within it. Picture a spiral galaxy slowly rotating in the depths of space. Its majestic arms, glittering with billions of stars, seem frozen in time, but that's an illusion. We now know these cosmic giants are not static. They pulse, they breathe, they have a heartbeat. This is our first phenomenon, galactic heartbeats, the rhythmic expansion and contraction of spiral galaxies like our own Milky Way. This isn't a vague metaphor, it's a measurable, astronomical reality. Through powerful telescopes and sophisticated simulations, astronomers have observed a fascinating pattern. The entire disk of a spiral galaxy doesn't just spin, it actually rises and falls, moving in and out like the chest of a breathing animal. Vast waves of gas and dust compress and expand, triggering bursts of star formation in cycles that can last tens of millions of years. One moment, the galaxy is contracting, pulling its material inward. The next, it's expanding outward as if taking a deep cosmic breath. What drives this incredible rhythm? It's a complex dance of powerful forces. The primary engine is gravity itself, the collective gravitational pull from all the stars, gas, and most significantly, the immense halo of dark matter surrounding the galaxy creates a natural tendency for the disk to oscillate. But there's more. Supernovae, the spectacular explosions of dying massive stars, act as a feedback mechanism. These colossal blasts inject tremendous energy into the surrounding gas, pushing it outward and contributing to the expansion phase of the cycle. It's a self-regulating system. Too much star formation leads to more supernovae, which then clear out the gas and temporarily slow down the birth of new stars, allowing the cycle to begin anew. This isn't a chaotic process, it's a remarkably regular, rhythmic pulse. The implications of this are profound. If galaxies have heartbeats, could the entire universe have a pulse? Some cosmologists theorize that these galactic rhythms might be synchronized with even larger cosmic cycles, perhaps influenced by the mysterious flow of dark matter filaments connecting galaxies or the overall expansion of the universe itself. This phenomenon moves us away from seeing the cosmos as a cold, inert clockwork and toward viewing it as a dynamic, almost biological entity. The galaxy isn't just a thing, it's a process. It's alive with motion and rhythm, a vast celestial being whose slow, steady heartbeat sets the tempo for the lives of stars and the potential for worlds within it. This rhythmic pulse is our first compelling clue that the universe operates with a regularity we once associated only with living systems. Just as the rhythmic pulse of a galaxy hints at a deeper cosmic vitality, the structure of the universe itself reveals an even more astonishing parallel to life. When cosmologists mapped the positions of millions of galaxies, they didn't find a random scattering of stars. Instead, they uncovered a vast, intricate architecture, a cosmic web of unimaginable scale and complexity. This is our second phenomenon, the universe as a cosmic neural network. Picture the largest structure known to exist, a web of dark matter filaments stretching billions of light years across the cosmos. Along these filaments, galaxies cluster like glowing nodes with immense, empty voids between them. This is not a static sculpture, it is the dynamic scaffolding of all existence, and its resemblance to the neural networks of a biological brain is nothing short of breathtaking. In this grand cosmic analogy, each galaxy can be seen as a neuron, a bright, active processing point. The dark matter filaments that connect them act as synapses, the intricate pathways that facilitate communication. This isn't merely a visual similarity, it's a functional one. Just as a thought or a memory in the brain is not located in a single neuron but is an emergent property of the entire network's activity, the properties of the universe, its evolution, its structure, its very nature, may be an emergent property of this cosmic web. Energy and information, in the form of gravity, light, and other fundamental forces, flow along these filaments, connecting galaxies and influencing their growth and behavior across incomprehensible distances. The implications of this structure are revolutionary, challenging the very core of what we believe about the cosmos. Such an organized filamentary network did not arise from pure randomness. It is the direct result of the universe's fundamental laws and initial conditions acting over billions of years. This points toward a cosmos that is inherently ordered and interconnected. Some theoretical physicists and cosmologists speculate that this vast network might not only facilitate the flow of physical material, but could also allow for a more fundamental form of cosmic communication, or even a substrate for a universal consciousness. The idea, known as panpsychism in philosophy, suggests that consciousness might not be a product of complex biology alone, but a fundamental property of the universe itself, with this cosmic web acting as its physical circuitry. This perspective transforms our understanding of our place in the universe. We are not just living on a tiny rock orbiting an average star in a random galaxy. We are participants within a single, gigantic, interconnected entity. The atoms that make up our bodies were forged in the hearts of long-dead stars and distributed along these very filaments of dark matter. We are not just in the universe, we are a part of its neural network, a tiny but conscious node in a vast, thinking cosmos. This cosmic web is perhaps the most compelling evidence that the universe operates not as a cold, dead machine, but as a unified, dynamic, and astonishingly complex whole. If galaxies are the beating hearts and the cosmic web is the nervous system, then stars are the universe's metabolic engines. They are the powerhouses that convert raw material into usable energy, driving the processes that make complexity and even life possible. This is our third phenomenon, stellar metabolisms. Deep within the core of every star like our Sun, an incredible alchemy is taking place. Under immense pressure and temperatures reaching millions of degrees, atoms of hydrogen are forced together, fusing into helium. This process of nuclear fusion releases a tremendous amount of energy, which radiates outward from the core, fighting against the star's own immense gravity to create a stable, glowing sphere. This is not so different from the metabolic processes in a living cell, where mitochondria take in nutrients and, through a series of chemical reactions, convert them into adenosine triphosphate, the energy currency that powers all cellular activity. A star takes the fundamental fuel of the universe and metabolizes it into the light and heat that sustain its own existence. But a star's influence extends far beyond its own fiery atmosphere. This energy output fundamentally shapes its local environment. The solar wind, a constant stream of charged particles flowing from the Sun, carves out a protective bubble in interstellar space called the heliosphere, shielding our planetary system from harmful cosmic radiation. The warmth from a star dictates whether planets in its orbit can host liquid water, a key ingredient for life as we know it. In this way, a star doesn't just live for itself. It actively creates and maintains the conditions necessary for a wider ecosystem to flourish. Its metabolic processes have direct and vital consequences for the worlds that circle it, much like how an organism's internal functions support the symbiotic bacteria within its gut. Perhaps the most profound parallel to life is the star's own life cycle. Stars are born within the dense, gaseous nurseries of nebulae. They mature through a long period of stable hydrogen fusion, and they eventually die. The manner of their death is what truly cements their role in a living cosmos. For smaller stars, death is a relatively quiet affair, leaving behind a cooling white dwarf. But for massive stars, the end is spectacular and generative. When they exhaust their nuclear fuel, their cores collapse catastrophically, resulting in a supernova explosion of unimaginable power. This violent death is ironically an act of cosmic creation. The incredible forces involved forge elements far heavier than helium, the carbon in our cells, the oxygen we breathe, the iron in our blood, and then blast them out across the galaxy, seeding nebulae with the enriched ingredients for new stars, rocky planets, and ultimately, life. This creates a beautiful, self-sustaining cycle. A star lives its life processing primordial hydrogen and helium. In its death throes, it manufactures and scatters the heavier elements. Those elements then become part of the next generation of stars and the planets that form around them. We are literally made of stardust, the recycled remnants of stars that died billions of years ago. This constant recycling of matter and energy, this stellar metabolism on a galactic scale, is what transforms the universe from a static collection of objects into a dynamic, evolving ecosystem. Stars are not mere inert light bulbs in the sky. They are active, transformative agents in a continuously regenerating cosmic environment, participants in a grand cycle of birth, death, and rebirth that is fundamental to a living universe. While stars act as the universe's metabolic engines, another even more powerful entity governs the heart of nearly every galaxy, acting as a central regulator of cosmic life. These are supermassive black holes, and their behavior is astonishingly similar to a digestive system. Imagine a colossal cosmic mouth, an event horizon from which nothing, not even light, can escape. This is not a mindless vacuum cleaner, but a sophisticated processor, as vast clouds of gas and dust and even entire stars are drawn inexorably toward a black hole. They don't just vanish. They form a swirling, superheated disk of material called an accretion disk, spinning at nearly the speed of light. Friction within this disk heats it to temperatures of millions of degrees, causing it to glow brilliantly across the electromagnetic spectrum. This is the cosmic equivalent of chewing and salivating, breaking down complex structures into their fundamental components. But the true marvel is what happens next. A black hole doesn't just consume, it also gives back. Through processes we are still striving to fully understand, black holes channel some of this immense gravitational energy into launching unimaginably powerful jets of radiation and particles from their poles. These jets, traveling a Chinese letter light speed, can shoot out for hundreds of thousands of light years, far beyond the boundaries of their host galaxy. This is the cosmic feedback mechanism. These jets pump enormous energy into the surrounding intergalactic medium, heating it up and preventing it from collapsing to form new stars. In this way, the central black hole acts as a master regulator, controlling the growth rate of its entire galaxy. If too much gas flows in, forming too many stars, the black hole's activity intensifies and its jets push back, slowing down the star formation process. It's a delicate balancing act that maintains galactic homeostasis, much like how our bodies regulate temperature or blood sugar to maintain a stable internal environment. This role as a galactic governor is profound, but some theories venture even further into the extraordinary. The laws of physics as we know them break down at the black hole's singularity, the point of infinite density. This has led to speculative but fascinating ideas that black holes might not be ultimate in points, but rather transformers or even portals. The concept of black holes acting as nodes in a vast cosmic network suggests they could be processing information and energy in ways that transcend our current understanding of spacetime. The holographic principle, a theory in quantum gravity, proposes that all the information that falls into a black hole might be encoded on its two-dimensional event horizon, like a cosmic hard drive. This implies that black holes are not merely destructive but are integral to the universe's information processing, perhaps even facilitating a form of cosmic recycling where matter and information are somehow repurposed. Ultimately, the existence and behavior of supermassive black holes paint a picture of a universe that actively manages its resources. They are the ultimate recyclers and regulators, ensuring that galactic ecosystems do not grow out of control. Their consuming nature is balanced by their generative feedback, a cycle of intake and output that is essential for the long-term evolution and stability of the cosmos. This intricate dance of destruction and creation mirrors the homeostasis found in all living organisms, providing a compelling argument that black holes are not monstrous anomalies but vital organs in a living, breathing universe. But if black holes are the universe's regulatory organs, then what is the fluid that flows through this cosmic body, carrying the nutrients and structure needed for life? The answer brings us to the most enigmatic substance in existence, dark matter. This is our fifth phenomenon, and it functions as the invisible lifeblood of the cosmos. We cannot see it, touch it, or directly detect it with any instrument we have yet devised, but we know it is there because of its overwhelming gravitational influence. It is the hidden scaffolding upon which the entire visible universe is built, a vast, unseen network that holds galaxies together and dictates their very motion. Imagine a circulatory system so immense it spans the entire cosmos, with dark matter as the plasma flowing through its veins, distributing the mass and energy that allow galaxies to form, evolve, and survive. The evidence for this cosmic circulation is everywhere we look. Stars at the outer edges of spiral galaxies orbit at speeds that should, according to the gravity of the visible matter alone, fling them off into the void. But they don't. They hold their course held firmly in the gravitational grip of an immense, invisible halo of dark matter that surrounds each galaxy like an unseen force field. This halo acts as a gravitational anchor, preventing galaxies from simply spinning themselves apart. On the largest scales, this effect is even more dramatic. The beautiful, filamentary cosmic web we explored earlier, that vast neural network of the universe, is woven not from visible galaxies, but from these dark matter highways. Dark matter clumped together first after the Big Bang, creating gravitational wells into which ordinary matter, the gas and dust that make up stars and planets, could later flow. Without this dark matter framework, the universe would be a formless, thin soup of hydrogen and helium. There would be no galaxies, no stars, no planets, and certainly no us. This role as a cosmic architect is profound, but the biological analogy goes even deeper. Just as a circulatory system is essential for growth and connectivity in a living organism, dark matter facilitates cosmic growth and connectivity on a grand scale. It is the medium through which galaxies interact and merge, its gravitational pull guiding them along the filaments of the web to collide and cannibalize one another, fueling new rounds of star formation and galactic evolution. This process of growth and exchange, governed by an unseen substance, is eerily reminiscent of how hormones or chemical signals in the body regulate growth and communication between organs. Furthermore, while dark matter is thought to interact only through gravity, some theories suggest it might have its own, very subtle forces. If so, there could be complex interactions and flows within the dark matter itself, a hidden dynamics operating in parallel to our visible reality, a secondary circulatory system we are only beginning to imagine. The mystery of what dark matter actually is remains one of the greatest puzzles in science. Is it a sea of exotic, undiscovered particles, a manifestation of gravity working differently on colossal scales? Or something even more strange and wonderful? Regardless of its ultimate nature, its function is clear. Dark matter is the fundamental organizer, the silent partner to visible matter that provides the structure and stability necessary for complexity to arise. It is the canvas upon which the bright paint of stars and galaxies is splashed, the unseen gravitational glue that binds the cosmos into a coherent, functioning whole. This makes it not a bizarre anomaly, but an essential component of a living, breathing universe, the indispensable lifeblood that flows through the veins of space-time, giving form and function to everything we see and know. Now, if dark matter is the cosmic lifeblood giving structure to the universe, and black holes are its regulatory organs, then what system allows for instantaneous communication across this vast celestial body? This brings us to one of the most baffling and profound discoveries in all of physics: quantum entanglement, a phenomenon that acts as the universe's own nervous system. At its heart, quantum entanglement is a connection so intimate and immediate that it defies everything we intuitively understand about space and time. It occurs when two particles, like photons or electrons, become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are separated. We could place one entangled particle in a lab on Earth and send its partner to the far side of the galaxy, and if we measure the spin of the one here, its distant twin will adopt a corresponding spin in that very same instant, seemingly communicating faster than the speed of light. This spooky action at a distance, as Albert Einstein famously called it, challenges the very foundation of classical physics, which holds that information cannot travel faster than light and that objects are separate, localized entities. Entanglement suggests instead that at the most fundamental level, the universe is not a collection of distinct things but a deeply interconnected web of relationships. This isn't a physical force traveling through space. It's a fundamental connectedness that operates outside of space and time as we know it. In this view, the vast distances between stars and galaxies become almost illusory, as particles can maintain a ghostly kinship that transcends the emptiness between them. This non-local connectivity implies that the universe is fundamentally whole and coherent, its parts forever in silent, instantaneous conversation with one another. The biological parallel is astonishingly clear. In a living organism, your nervous system allows you to feel a pinprick on your finger the moment it happens. The signal travels at a finite speed along your nerves to your brain, but the experience is one of immediate connection between the different parts of your body. Quantum entanglement appears to be the universe's version of this, a fundamental, instantaneous linkage that binds the cosmos into a single, responsive entity. It's as if the universe has its own sensory network, where an event in one location can register elsewhere without any discernible delay, creating a kind of cosmic synchronicity that hints at a deeper, underlying unity. This has led some pioneering physicists and philosophers to venture into truly radical territory. They propose that this quantum connectedness might form the substrate for a form of universal consciousness or a fundamental level of communication that permeates all of reality. The idea is that if every particle can be instantly linked to another, then the entire universe could be woven together into a single, conscious field. In this model, the cosmos isn't just a place where conscious beings like us randomly evolved. Consciousness itself might be a primary feature of the universe, with entanglement serving as its physical mechanism. Our individual minds, then, might not be isolated consciousnesses looking out at an external world, but rather localized expressions of a vast, cosmic mind experiencing itself through countless perspectives. This phenomenon fundamentally shatters our conventional notion of separateness. We are taught to see ourselves as isolated individuals living on a small planet in a mostly empty universe. Quantum entanglement suggests a completely different story, that we and every particle we are made of are intimately and instantly connected to the whole of existence. The distance between you and a distant star is not a void of separation but a space filled with potential connection, a web of relationships waiting to be observed. This doesn't just change our understanding of physics, it transforms our understanding of reality itself, pointing toward a universe that is not a cold, mechanical void but a living, coherent, and deeply interconnected being, aware of itself in every part. This astonishing interconnectedness revealed by quantum entanglement suggests a universe that is fundamentally whole. But how does this unified reality generate the breathtaking diversity of forms we see around us? The answer may lie in a hidden code, a kind of cosmic blueprint that repeats itself at every scale of existence. Look closely at a frozen river delta, its tributaries branching out like veins against the white ice. Now pull back and observe the image of a distant galaxy, its spiral arms swirling in a pattern that is hauntingly familiar. They are not the same, yet they share an underlying architecture, a self-similar, repeating pattern known as a fractal. This is our seventh phenomenon, cosmic DNA, the replication of patterns across all scales of the universe, suggesting a shared set of instructions for building reality itself. This repetition is not a coincidence. It is a direct consequence of the universal laws of physics and mathematics playing out in different contexts. Gravity, fluid dynamics, and electromagnetic forces conspire to create structures that are efficient, stable, and scalable. A lightning bolt forks because that is the most efficient way for electrical energy to discharge through the atmosphere. A tree branches because that is the most effective way to expose its leaves to sunlight and transport water from roots to canopy. A galaxy forms spiral arms because that is a stable configuration for a rotating disk of stars and gas under the influence of gravity. The same fundamental principles, acting on vastly different materials and across incomprehensible distances, yield forms that feel eerily familiar. It's as if the universe has a favorite set of designs, a toolkit of patterns it returns to again and again. This points toward a profound idea that there might be a universal code or a fundamental set of algorithms governing the growth and evolution of everything, from the quantum foam to the cosmic web. In biology, DNA provides the instructions for building an organism, ensuring that a maple tree produces seeds that grow into more maple trees, not oak trees. The cosmos appears to operate on a similar, albeit more abstract, principle. The laws of physics are its genetic code. These laws dictate how energy condenses into matter, how that matter clumps together under gravity, and how complex structures emerge from simplicity. The fractal patterns we see are the phenotypic expression of that code, the visible outcome of the universe's inherent operating system. This doesn't mean the universe has a literal strand of DNA, but rather that it evolves and builds itself according to a consistent, reproducible set of rules that generate order out of chaos. The implications of this cosmic DNA are truly mind-bending, as they begin to dissolve the hard line we've drawn between the living and the non-living. We consider a growing crystal to be an inorganic process, while we see a growing fern as organic life. Yet, both exhibit fractal patterns, both follow the laws of physics to maximize their growth and stability, and both are expressions of the universe's inherent tendency toward self-organization. This suggests that life as we know it is not an anomaly separate from the cosmos, but is rather the most complex and conscious expression of these universal formative principles. The swirl of a galaxy and the swirl of a snail's shell are not metaphorically related. They are literally, physically related through the shared mathematical language of nature. We are not living in a universe that sometimes produces life. We are living in a universe that is inherently alive with formative potential, a universe that is constantly building, evolving, and expressing itself through an endless repetition of its most beautiful and efficient patterns. But this intricate web of quantum connection and fractal patterning isn't confined to the abstract realms of the very small or the unimaginably large. It manifests brilliantly right here in our own celestial neighborhood. We often think of our solar system as a collection of separate, silent worlds orbiting a central star, but this view is rapidly becoming outdated. A closer look reveals a dynamic and deeply interconnected community, a delicate dance of forces that functions much like a thriving ecosystem. This is our eighth phenomenon, planetary systems as ecosystems, where planets, moons, and countless smaller bodies interact in a complex ballet that creates and maintains the conditions for stability and, potentially, life. Consider the concept of orbital resonances, a gravitational phenomenon that creates stunning harmonies within this cosmic ecosystem. This occurs when orbiting bodies exert a regular, periodic gravitational influence on each other, often because their orbital periods are related by a ratio of small whole numbers. A beautiful example can be found with three of Jupiter's largest moons, Io, Europa, and Ganymede. For every 4 orbits that Io makes around Jupiter, Europa completes exactly 2 orbits and Ganymede completes 1. This precise clockwork rhythm keeps their orbits stable and prevents them from perturbing each other into chaotic paths. It's a gravitational lockstep that has likely persisted for billions of years, a celestial harmony that maintains order within the Jovian system. This isn't a random occurrence, it's a self-regulating feature that emerges naturally from the laws of physics, creating a stable environment much like the balanced predator-prey relationships that maintain stability in a terrestrial forest. Within this balanced system, individual planets often take on specialized roles that benefit the whole community. Jupiter, the gas giant of our solar system, acts as a grand protector, a gravitational guardian for the inner terrestrial planets. Its enormous mass acts like a cosmic vacuum cleaner, sucking in or deflecting a significant number of comets and asteroids that might otherwise hurtle toward the inner solar system. This protective role has profoundly shaped the history of Earth, potentially reducing the frequency of catastrophic extinction-level impacts and allowing life the relative peace it needed to evolve and flourish over eons. Conversely, smaller bodies like asteroids and comets are not just silent rocks, they are the delivery vehicles of the ecosystem. They are believed to have brought vast quantities of water and complex organic molecules to the early Earth, seeding our planet with the essential ingredients for life. This exchange of material, this transfer of cosmic resources, is a fundamental process in any ecosystem. And then there is Earth itself, which presents the most compelling case for a planetary ecosystem through the Gaia hypothesis. This concept, proposed by scientist James Lovelock, suggests that our planet functions as a single, self-regulating system where the biosphere, the sum of all life, actively works to maintain the conditions necessary for its own survival. Life doesn't just passively exist on Earth, it shapes the planet. Microbial life in the oceans generates gases that influence cloud formation and global temperature. Plants regulate the composition of the atmosphere through photosynthesis, maintaining oxygen at levels suitable for their own respiration and for animal life. The entire planet behaves like a living superorganism, with countless feedback loops between its geology, atmosphere, and biology, all working in concert to preserve a stable, habitable state. This isn't just a metaphor, it's an observable scientific reality that demonstrates how a planet can actively manage its own health. This perspective completely transforms our understanding of a solar system. It is not a static arrangement of rocks and gas isolated in the void. It is a vibrant, interactive, and deeply interconnected network. The gravitational tugs, the exchange of material through impacts, the resonant orbits, and the regulatory feedback of a living planet like Earth all point to a system that is far more than the sum of its parts. Our solar system is a complex, co-evolving community where each member, from the largest gas giant to the smallest asteroid, plays a role in the overall health and stability of the whole. We are not just inhabitants of a single planet, we are participants in a vast solar-wide ecosystem, a single, integrated entity within the even grander living cosmos. Just as our solar system thrives as a complex, interdependent ecosystem, each individual planet within it possesses its own dynamic systems that actively engage with the cosmic environment. Perhaps the most stunning example of this is the invisible force field that envelops our own world, a protective barrier that doesn't just statically exist, but rhythmically pulses in a direct conversation with the Sun. This is Earth's magnetosphere, and its constant expansion and contraction is a breathtaking phenomenon known as magnetospheric breathing. Generated by the churning of molten iron in our planet's core, this magnetic bubble extends tens of thousands of kilometers into space. But it is far from a rigid shield. Instead, it behaves like a living lung, continuously inflating and deflating in response to the solar wind. a relentless stream of charged particles constantly flowing from the Sun. When the Sun is calm, the magnetosphere rests in a more relaxed state. But when our star erupts with a solar storm or a coronal mass ejection, hurling billions of tons of plasma outward at millions of miles per hour, this immense wave of energy slams into Earth's magnetic field. The force of this impact compresses the sunward side of the magnetosphere, sometimes by half its size, as if the entire field is taking a deep, bracing breath in. Then, as the storm passes, the field exhales, expanding back outward and even beyond its original boundaries. This isn't a passive event, it's an active, dynamic response. The magnetosphere absorbs this incredible energy, reshapes itself, and channels the solar wind around the planet, preventing it from stripping away our atmosphere and bathing the surface in lethal radiation. It is our planet's first and most vital line of defense, a guardian that is constantly working, constantly adjusting, and literally breathing in time with the rhythms of our parent star. The most beautiful and visible signature of this cosmic exchange is the aurora. The shimmering curtains of green, red, and purple light that dance across the polar skies are not merely a pretty light show, they are the direct result of this breathing process. As the solar wind is funneled by the magnetic field toward the poles, it energizes molecules of oxygen and nitrogen in the upper atmosphere, causing them to glow. The aurora is the breath of the magnetosphere made visible, a brilliant and awe-inspiring testament to the active, energetic dialogue between the Earth and the Sun. It is the universe showing us, in the most spectacular way, that our planet is not an isolated island but an engaged participant in a continuous flow of cosmic energy. And this phenomenon is not unique to Earth. We have sent spacecraft to other worlds and found them engaging in their own versions of this magnetic dance. Jupiter, with its incredibly powerful magnetic field generated by a vast interior of metallic hydrogen, has a magnetosphere so large that if it were visible in our night sky, it would appear larger than the full moon. This Jovian shield breathes on a colossal scale, interacting with the solar wind and with particles spewed from its volcanic moon, Io, creating intense radiation belts and brilliant auroras that ring its poles. Even Mars, which lost its global magnetic field billions of years ago, possesses localized, fossilized magnetic domains in its crust that still interact weakly with the solar wind, a ghostly echo of a once powerful protective pulse. The presence of these magnetic personalities around other planets confirms that this is a universal process, a fundamental way that celestial bodies manage energy, protect their interiors, and interact with their stellar environment. This active management and adaptation is a hallmark of living systems. Our planet doesn't just sit in the path of the solar wind. It responds, it changes its shape, it absorbs energy, and it finds a new equilibrium. This process of maintaining a stable internal environment despite external changes is known as homeostasis, and it is a critical characteristic of life. Earth's magnetosphere provides planetary-scale homeostasis, safeguarding the delicate chemical balances of our atmosphere and oceans that allow biology to thrive. It shows us that a planet can be more than a rock. It can be a complex, responsive system that actively works to preserve the conditions necessary for complexity and life. In the rhythmic breathing of this magnetic shield, we see a profound example of the universe's innate capacity for protection, adaptation, and dynamic balance. Just as our planet experiences the reliable turn of spring, summer, fall, and winter, the cosmos itself undergoes grand, rhythmic cycles that shape its destiny over billions of years. This is the concept of cosmic seasons, vast periods of transformation driven by the most powerful forces in the universe. These aren't seasons measured in months, but in epochs, each one leaving an indelible mark on the structure and character of the cosmos. We see this cyclical pattern everywhere we look. A galaxy might enjoy a long, stable summer of steady star formation, only to be thrown into a turbulent autumn by a collision with a neighboring galaxy. This violent merger triggers a spring of intense stellar birth as clouds of gas are compressed, igniting a firestorm of new suns. Later, the ferocious energy from those new stars and the supernova explosions of the dying ones will blow away the remaining gas, leading to a dormant winter where star formation effectively ceases. This cycle of birth, chaos, death, and renewal is not a one-time event but a repeating rhythm that galaxies experience throughout their long lives. The engine behind these cycles is the relentless pull of gravity and the mysterious push of dark energy, working in a cosmic tug of war across the eons. Gravity wants to pull things together. It builds galaxies, draws them into clusters, and fuels the birth of stars. Dark energy, on the other hand, is the force causing the accelerated expansion of the universe, pushing galaxies apart and stretching the very fabric of space-time. The current era of the universe is dominated by this dark energy expansion, a long, slow cosmic summer where galaxies are increasingly isolated from one another. But theories abound that this might not always be the case. Some models suggest that this expansion could one day halt, reverse, and lead to a big crunch, a gravitational collapse of the entire universe back into a state of incredible density. This would be the ultimate cosmic winter, a finale that could, in turn, seed another big bang and a new universe, a breathtaking cycle of death and rebirth on the grandest possible scale. This idea of a cyclical universe of cosmic seasons repeating forever resonates deeply with patterns we see in nature on Earth. A forest fire, while destructive, clears the way for new growth, enriching the soil with ash and allowing sunlight to reach the ground for a new generation of plants. In the same way, the death of a star in a supernova is a cataclysmic event that scatters the heavy elements necessary for planets and life throughout the galaxy, fertilizing the cosmos for future creation. These parallels suggest that the universe operates on principles of balance and regeneration that are universal, playing out from the smallest ecosystem to the largest galactic cluster. The universe isn't moving in a straight line toward a silent, cold end. It is participating in a dynamic, perhaps eternal, dance of transformation, constantly recycling itself in new and brilliant ways. This view of a seasonally changing cosmos reinforces the idea that we are part of a living, breathing, and evolving entity, one that knows both the vibrant explosions of creation and the quiet, dormant periods of rest. While our planet breathes in rhythm with the sun and the cosmos moves through its grand seasonal cycles, there is a more fundamental messenger that weaves through all of these processes, connecting every point in space and time, light itself. We often think of light as simply the illumination that allows us to see, but it is so much more than that. It is the universe's ultimate carrier of information, a constant stream of data flowing from every star, galaxy, and particle, telling the story of what was, what is, and even what might be. Every photon that reaches your eye from a distant star is a tiny packet of information that has been traveling for years, centuries, or even millennia, bringing you a first-hand report of its origin. The color of that light tells us what elements that star is made of. Its intensity reveals its size and temperature, and subtle shifts can even indicate planets orbiting around it. Light is the medium through which the cosmos communicates its state, its history, and its composition across the unimaginable void. This role as an information carrier takes on a truly bizarre and profound dimension in the realm of quantum physics, where the simple act of observation becomes inextricably linked with the nature of reality itself. The famous double-slit experiment is a perfect example of this deep mystery. When scientists fire particles like electrons at a barrier with two slits, they behave in a way that defies common sense. If no one is watching, the particles act like waves, passing through both slits at once and creating an interference pattern on the detector behind them. But the moment an observer sets up a device to measure which slit each particle goes through, the behavior changes instantly. The particles suddenly act like tiny bullets, going through one slit or the other, and the interference pattern vanishes. It's as if the particle knows it's being watched and changes its behavior accordingly. This suggests that the act of observation, of gaining information, is not a passive process but an active one that somehow collapses possibilities into a single reality. This leads us to a radical and awe-inspiring possibility, that light and consciousness are not separate phenomena but are deeply intertwined in the very fabric of existence. In this view, light isn't just carrying information to a conscious observer. It is the very medium through which observation and reality interact. The photon is the fundamental messenger that facilitates the relationship between the observer and the observed, making the universe a participatory phenomenon. Without an observer to measure it, a photon exists in a blur of probabilities, a cloud of potentiality. It is the interaction, the measurement, that forces it to choose a state, to become a specific piece of information in a specific place and time. This has led some physicists and philosophers to propose that the universe might possess a form of photonic consciousness, a vast, underlying awareness for which light acts as both the medium and the message, connecting all things in a seamless web of perception. If this is true, then every ray of sunshine, every glimmer of starlight, is more than just energy. It is a thread in the cosmic nervous system, an instantaneous line of communication that allows the universe to know itself. We are not just beings who have evolved to see light. We are nodes in this network, focal points where the universe becomes self-aware. Our eyes and our instruments are not looking at the universe from the outside. They are instruments of the universe looking back at itself. The light that fills the cosmos is what allows this introspection to happen, making the universe not a cold, empty void but a responsive, communicative, and conscious entity, constantly engaging in a dance of information exchange that defines the very nature of reality. But if light is the universe's primary messenger, carrying information across the vastness of space, then gravitational waves are its deepest, most fundamental pulse, a vibration that travels through the very fabric of reality itself. For centuries, we thought of space as a static, unchanging stage upon which the drama of the cosmos played out. But Albert Einstein's theory of general relativity painted a radically different picture, one where space and time are woven together into a single, flexible fabric called spacetime. And just as a drum skin vibrates when you strike it, Einstein predicted that the most violent and energetic events in the universe, colliding black holes, merging neutron stars, even the Big Bang itself, would send ripples or gravitational waves racing outward through this cosmic fabric at the speed of light. For 100 years, this was just a brilliant mathematical prediction, a ghostly echo we had no way of hearing. That all changed in 2015 when the Laser Interferometer Gravitational Wave Observatory, or LIGO, made the first direct detection of these ripples, opening an entirely new window on the universe and confirming that spacetime is not a silent stage, but a dynamic, living membrane that rings like a bell. The events that generate these waves are almost beyond comprehension. Imagine two black holes, each with masses tens of times greater than our Sun, locked in a final, fatal dance. They spiral toward each other, moving at a significant fraction of the speed of light, churning the space-time around them into a frenzy. When they finally merge into a single, more massive black hole, an amount of energy equivalent to several times the mass of our Sun is converted, in a fraction of a second, into a violent outburst of gravitational waves. The resulting ripple in space-time is incredibly subtle by the time it travels over 1 billion light-years to reach us, distorting the fabric of reality by a distance thousands of times smaller than the nucleus of an atom. Yet, LIGO incredibly precise instruments with their multi-kilometer, long laser arms are designed to detect exactly this minuscule stretching and squeezing, translating it into an audible chirp, a literal sound that marks the heartbeat of a cosmic collision. This ability to hear the universe fundamentally changes our perception of the cosmos. Before gravitational wave astronomy, our view of the universe was almost entirely based on light. We were essentially watching a silent movie. But now we have the sound turned on. We can listen to the universe's most powerful events. Each detection is like a unique heartbeat, its rhythm and tone telling us a specific story about the objects that created it, their masses, their spins, and their final moments. This isn't just about confirming a century-old theory. It's about gaining a new sense with which to explore reality. We are now tuning in to the vibrations of the cosmos, listening to the background hum of countless merging events and the singular, thunderous crashes of the most colossal collisions, building a symphony of the universe's dynamic activity. The profound implication of this phenomenon is that the universe is not just filled with motion. Its very substance is motion. Space-time itself is alive with vibration, constantly quivering in response to the dance of matter and energy within it. Every massive object that moves creates its own tiny, undetectable gravitational wave, contributing to a faint, universal shimmer. The cosmos is not a rigid, fixed structure but a fluid, elastic, and responsive entity. The detection of gravitational waves is the ultimate proof that the universe is a dynamic process, not a static collection of things. It pulses, it rings, it vibrates with the rhythm of creation and destruction, reminding us that even in the deepest void, there is no true stillness, only the constant, humming heartbeat of a living, evolving cosmos. This intricate dance of cosmic communication and vibration reveals a universe that is deeply interconnected. But these relationships become even more intimate when we consider the bonds that form within individual star systems. We often picture a star as a brilliant, solitary monarch, with planets as its silent, obedient subjects orbiting in mute servitude. But this hierarchy is an illusion. The true relationship is far more nuanced and collaborative, a profound partnership of mutual benefit and influence that echoes the most vital symbiotic relationships in nature. This is cosmic symbiosis, the 13th phenomenon on our journey, and it reveals that stars and planets are not isolated entities but interdependent partners in a cosmic dance that fosters complexity and ultimately life itself. At its most fundamental level, this symbiosis is an exchange of energy for substance. The star, of course, is the provider of energy. It is a relentless furnace, flooding its planetary system with the light and heat that provide the fundamental power for any activity. This energy drives weather systems on planets, melts icy moons from within, and provides the activation energy for the complex chemistry that can lead to life. Without the star's constant outpouring, the planets would be frozen, dark, and inert. But what do the planets offer in return? They provide the raw materials and the stable environments where the universe's potential can be realized. A planet, particularly a rocky one like Earth, is a crucible. It holds within it the heavy elements, the carbon, oxygen, iron, and silicon forged in the heart of a long-dead star. It has the gravity to hold onto an atmosphere and the geologic activity to cycle nutrients and regulate temperature. In essence, the star provides the spark and the planet provides the workshop. This is a mutualism as elegant as that between a flowering plant and a bee. The plant offers nectar, and the bee enables the plant's reproduction. One cannot truly thrive without the other. This partnership, however, goes far beyond a simple one-way transaction. Planets are not passive recipients of stellar energy. They actively give back and influence their sun. One of the most fascinating mechanisms for this is tidal forcing. While we're familiar with our moon's gravity pulling on Earth's oceans to create tides, a planet can exert a similar, though subtler, gravitational pull on its star. In very close orbits, like that of a hot Jupiter-class planet, the planet's gravity can actually tug on the star's outer layers, creating bulges and stirring up its magnetic activity. This can lead to increased starspot activity and more frequent and powerful stellar flares. It's as if the planet is actively massaging its star, altering its behavior from a distance. Furthermore, a planet with a strong magnetic field of its own, like Jupiter, can interact directly with the star's magnetic field and the solar wind, creating a complex boundary that channels energy and protects the inner planets. The planet becomes a key player in managing the energy flow within its own system, a regulator in the stellar-planetary relationship. This feedback loop creates a dynamic, co-evolving system where the fate of the star and its planets are deeply intertwined. The presence of planets can influence the star's rotation and its long-term evolution. Conversely, the star's activity dictates the planetary environments, determining which worlds might retain their atmospheres and which become barren wastelands. They are not separate things, they are parts of a single, integrated whole. This perspective completely reframes our understanding of a solar system. It is not a monarchy with a star ruling over passive subjects. It is a symbiotic ecosystem, a cosmic collaboration where each member, from the largest gas giant to the smallest rocky world, plays a role in the health and stability of the whole. The star gives the gift of energy, and the planets offer the potential for form, complexity, and consciousness in return, working together to create something far greater than the sum of their parts. This intricate interdependence is yet another powerful thread in the tapestry of a living, breathing cosmos. After witnessing the intricate symbiotic dance between stars and their planets, we naturally wonder where this beautiful partnership begins. The answer lies in the most breathtaking and fertile regions of our galaxy, vast, swirling clouds of cosmic potential known as nebulae. These are not merely pretty clouds, they are the universe's maternity wards, the active nurseries where the raw stuff of existence coalesces into new suns and worlds. Within these glowing cradles, we find our 14th phenomenon, a process so beautifully analogous to biological birth that it feels less like a metaphor and more like a universal principle in action. A nebula begins as a relatively diffuse cloud, primarily composed of hydrogen and helium gas with a sprinkling of dust, the ashes of long-dead stars. For millions of years, it may drift undisturbed. But then a trigger arrives. It could be the shock wave from a nearby supernova explosion, or the gentle gravitational nudge as the cloud passes through a spiral arm of the galaxy. This disturbance creates a slight density fluctuation, a tiny pocket where gravity suddenly gains a slight advantage, and from that moment, an irreversible process begins. That small knot of gas begins to pull inward, its own gravity growing stronger as it draws in more material from the surrounding cloud. This is the cosmic equivalent of conception, the initial spark that sets a grand gestation in motion. As this pocket collapses, it begins to spin and flatten into a swirling disk, much like a ball of pizza dough spinning into a flat crust. At the heart of this disk, a protostar forms, a furious, hot, and dense core that is not yet a true star. For hundreds of thousands of years, this infant sun continues to feed, accreting mass from the disk that encircles it. Meanwhile, in the disk itself, another miracle is unfolding. Dust grains of silicates and carbon, along with ices of water, methane, and ammonia, begin to stick together in a process called accretion. Tiny particles collide and cling, growing into pebbles, then rocks, then planetesimals, the building blocks of planets. This is the differentiation phase, where the materials that will become terrestrial worlds like Earth and gas giants like Jupiter begin to sort themselves out, with heavier materials staying closer to the young star and lighter gases and ices dominating the outer regions. The climax of this celestial birth process is ignition, when the pressure and temperature at the core of the protostar becomes sufficiently extreme, reaching a staggering 10 million Kelvin. A sustained nuclear fusion reaction is triggered. Hydrogen atoms are forced together to form helium, and a torrent of energy is released. The newborn star literally turns on, blowing away the remaining gas in its stellar nursery with a powerful stellar wind and flooding its new planetary system with light. This is the moment of delivery, the first breath of a star that will now shine for billions of years. The remaining material in the disk, now cleared of gas, continues to clump together to form planets, asteroids, and comets, completing the formation of a new solar system. This entire process, from a quiet cloud to a shining new family of worlds, is a stunning display of the universe's inherent creativity and regenerative power. Nebulae are the ultimate evidence that the cosmos is not a static museum of old relics, but a dynamic, living factory, constantly giving birth to new possibilities. The complex organic molecules we've discovered within these clouds, the precursors to the chemistry of life, only deepen this connection. They are the cosmic amniotic fluid, rich with the ingredients for future complexity. Every atom that makes up our bodies, our planet, and our sun was once part of such a cloud, forged in a previous stellar generation, and then seeded into a nursery to begin the cycle anew. In the vibrant glow of a nebula, we are witnessing the universe's most fundamental and beautiful act, the perpetual act of creation itself. Yet, if black holes do not destroy information but somehow preserve it, a new and even more radical idea emerges, one that suggests the entire universe might be functioning like a cosmic hard drive. This leads us to the holographic principle, a theory that stands as one of the most mind-bending concepts in all of modern physics. It proposes that all the information that makes up our rich, three-dimensional reality, every star, every planet, every person, every thought, might actually be encoded on a two-dimensional surface at the very boundary of the universe. Imagine the universe as a magnificent, immersive movie. The holographic principle suggests that everything we see and experience is merely a projection, a hologram, emanating from a flat, two-dimensional surface that contains all the information needed to generate the entire three-dimensional show. In this view, the event horizon of a black hole acts as a kind of local example of this principle, a tiny patch of this cosmic screen where information is stored with incredible density. This isn't just a wild speculation, it's a serious attempt to reconcile gravity with quantum mechanics, and it implies that the universe is not just storing information locally, but is fundamentally made of information. Reality itself might be a kind of illusion, a magnificent projection from a deeper, simpler layer of existence. This concept of a universal memory bank resonates powerfully with the biological processes of living beings. In our own brains, memories are not stored as little videos or pictures. They are encoded in the complex connections between neurons, in the strength of synapses, and in the patterns of electrical and chemical signals. Our past experiences are physically etched into the structure of our brains, and they directly shape how we perceive the present and respond to the future. This is the essence of learning and adaptation. If the universe operates on a similar principle, with every event from the birth of a star to the fall of a leaf encoded on some fundamental level, then it too could possess a form of memory. It would have a complete and total record of its own history, a cosmic autobiography written in the language of physics on the fabric of space-time itself. This record wouldn't be for mere nostalgia. It could actively influence the universe's ongoing evolution. The staggering implication is that a universe with memory is a universe with the potential to learn and adapt. In biology, an organism that remembers which foods are poisonous or which environments are safe has a far greater chance of survival and growth. Its memory directly informs its future behavior. If the universe retains information, could it too be engaged in a process of cosmic learning? Could the laws of physics themselves be subtly evolving based on this accumulated historical data, fine-tuning the cosmos for greater complexity and stability over vast stretches of time? This idea transforms the universe from a passive arena governed by fixed rules into an active, participatory entity that is shaped by its own past. It suggests a cosmos that is not just alive in the present moment, but one that carries its entire history within it, using that memory as a guide for its endless journey into the future. This profound connection between information, memory, and adaptation provides a breathtaking new lens through which to view the cosmos, not as a cold, mechanical system, but as a living, learning, and remembering being of unimaginable scale and wisdom. This idea that the cosmos might possess its own memory and capacity for learning is staggering. But what if the universe's living nature extends beyond abstract information processing to the actual, physical propagation of life itself? We often assume that life is a rare and precious spark, a fragile anomaly that somehow flickered into existence on our one lucky planet. But what if we have it backwards? What if life is not a solitary accident, but a fundamental, widespread, and even inevitable feature of the cosmos? This brings us to our 16th phenomenon, a theory that radically reframes our place in the universe: Panspermia, the concept that life's building blocks, or even living microorganisms themselves, can and do travel between planets, moons, and even star systems, seeding life wherever they find a welcoming environment. The mechanism for this cosmic gardening is both simple and profoundly elegant. Imagine a large asteroid or a comet slamming into a world like early Mars, when it may have had oceans and a thicker atmosphere. The tremendous impact would blast countless tons of rock and soil into space. Locked within that ejected material could be hardy microorganisms that had thrived deep within the Martian crust. These tiny biological passengers, encased in their protective rocky vessels, then begin an incredible journey across the solar system. For millions of years, this fragment of Mars drifts through the void until eventually its path intersects with another world, our own. It streaks through Earth's ancient atmosphere as a meteorite, and while the outer layers burn away from the heat of entry, the interior remains cool, safely delivering its microbial cargo to the surface of a young, wet, and fertile Earth. In this scenario, we are not the original children of Earth. We are all potentially Martians, the descendants of biological pioneers that arrived on a celestial lifeboat. This is not mere science fiction. We have compelling evidence that makes this scenario not just possible, but plausible. We have already found meteorites on Earth that were definitively identified as chunks of Mars, blasted off its surface by ancient impacts. More astonishingly, when scientists analyze certain carbon-rich meteorites, called carbonaceous chondrites, they find them loaded with organic compounds, the very building blocks of life. Amino acids, the components of proteins and nucleobases, the ingredients of DNA and RNA, have been discovered in these space rocks. the universe, it seems, is not just making the raw materials for stars and planets. It is pre-packaging the fundamental chemistry required for biology. Furthermore, we have discovered extremophiles here on Earth, microbes that thrive in conditions of extreme heat, cold, radiation, and pressure that could easily survive the harsh conditions of interplanetary travel. Experiments on the International Space Station have shown that certain bacteria and even tardigrades, those microscopic water bears, can survive for years on the outside of the station, exposed to the vacuum of space and intense solar radiation. The resilience of life is far greater than we ever imagined, making the concept of a journey between worlds not a death sentence, but a viable mode of travel. The implications of Panspermia are nothing short of revolutionary for our understanding of life's place in the cosmos. If this theory holds true, then life is not an earthly accident. It is a cosmic imperative. The universe appears to be hardwired not just for chemistry and physics, but for biology. It actively disseminates the seeds of life, using asteroids and comets as its delivery vehicles, fertilizing promising planets wherever they may be. This transforms our view of the cosmos from a cold, mostly dead void into a fertile, living environment, a grand ecosystem on a galactic scale. A planet is not an isolated island where life must miraculously invent itself from scratch against impossible odds. Instead, it is a potential garden, a patch of soil waiting for the rain of cosmic seeds. If the conditions are even remotely right, life may already be on its way, having been delivered countless times throughout the planet's history. This suggests that life could be ubiquitous throughout the galaxy, a common feature of solar systems, with a shared cosmic ancestry that connects every living world in a vast biological family tree. We are not alone in the universe. We are kin to whatever might be growing in the soils of Enceladus or swimming in the subsurface oceans of Europa, all part of the same grand, living tapestry woven by the universe itself. Just as a living organism breathes rhythmically, inhaling and exhaling to sustain its vital processes, so too might the entire cosmos be engaged in a grand, slow-motion act of respiration. For nearly a century, we have known that our universe is expanding, with galaxies rushing away from one another as if propelled by some immense, unseen force. This discovery alone was revolutionary, painting a picture of a dynamic, evolving cosmos rather than a static, eternal one. But the story became even more astonishing at the turn of the millennium, when astronomers made a shocking discovery. This expansion isn't just continuing, it's accelerating. Some mysterious repulsive force, which we've dubbed dark energy, is acting against gravity's pull, pushing galaxies apart at an ever-increasing rate. This cosmic acceleration is the universe's great exhale, a powerful and steady outward breath that has been ongoing for billions of years, stretching the very fabric of space-time itself. Yet, many theoretical models suggest this exhalation may not be the final word. Before the discovery of dark energy, the ultimate fate of the universe was thought to hinge on a simple cosmic tug of war between the outward momentum of the Big Bang and the inward pull of gravity. If there was enough matter, gravity would eventually win, slowly halting the expansion and reversing it. All galaxies would begin rushing back toward each other, culminating in a cataclysmic event known as the Big Crunch, a fiery, ultra-dense collapse mirroring the Big Bang in reverse. This would be the universe's great inhale, a drawing in of all energy and matter back to a singular point. In this cyclical model, the Big Crunch might not be an end, but a transformation, potentially rebooting the universe in a new Big Bang, leading to an eternal cycle of expansion and contraction, of exhalation and inhalation, a cosmic breath repeating across eternity. Whether the universe ends in a freeze or a fire, a forever expansion or a dramatic collapse, its dynamic nature is undeniable. This constant state of flux, this inherent motion and change, is a fundamental characteristic of living systems. In biology, homeostasis is the process by which organisms maintain a stable internal environment through constant adjustment and change. Similarly, the universe's expansion and its potential contraction can be seen as a form of cosmic homeostasis, a vast balancing act between competing fundamental forces. The rhythm of this process, whether a single, long exhale or a repeating cycle, evokes the most essential rhythm of life itself, respiration. We breathe to take in oxygen for energy and expel carbon dioxide, a waste product. On a cosmic scale, the universe's expansion disperses energy and matter, allowing for the formation of stars and galaxies, while a potential contraction would recycle that same material, creating the potential for new creation. It is a metabolic cycle of unimaginable scale. This perspective transforms our understanding of the cosmos from a cold, mechanical arena into a living, breathing entity. We are not merely inhabitants of this breathing universe, we are part of its breath. The atoms that make up our bodies are being carried along on this grand exhalation, participants in a cosmic process that has been underway for 13.8 billion years. The universe is not a static backdrop for life. It is a dynamic, participatory phenomenon whose very motion and rhythm are prerequisites for the existence of stars, planets, and conscious beings like us who can observe and contemplate its magnificent breath. This vision of a respiring cosmos invites us to feel a deeper connection to the universe, not as something separate from us, but as a vast, living whole of which we are an intimate and inseparable part. We often think of solar flares as violent, dangerous eruptions, and from a human perspective, they certainly can be. These sudden flashes of increased brightness on the sun, often accompanied by coronal mass ejections that hurl billions of tons of superheated plasma into space, have the potential to disrupt satellites, knock out power grids, and pose radiation risks to astronauts. But what if we're only seeing one side of this cosmic coin? What if, on a grander scale, these stellar outbursts are not acts of mindless destruction, but rather essential regulatory functions, a cosmic immune system actively working to maintain the health of a star and its entire planetary family? This idea reframes our understanding of stellar activity entirely. Just as our own bodies use fevers and inflammation to fight off pathogens and reset our internal balance, a star like our Sun uses flares and ejections to manage its own complex energy system and protect its celestial domain. The Sun is a dynamic magnetic powerhouse. Its interior is a churning cauldron of plasma, and this motion generates a massive magnetic field that becomes twisted and tangled over time. These magnetic knots store enormous amounts of energy. A solar flare is essentially the sudden snapping and reconnecting of these magnetic field lines, an explosive release of pent-up energy that acts as a pressure valve for the entire stellar system. It's the star's way of preventing a catastrophic buildup of magnetic stress, of releasing excess energy to return to a state of equilibrium. This self-regulation is a hallmark of a system that is actively managing its own stability, not just a simple ball of gas passively burning away. The protective benefits of this activity extend far beyond the Sun itself, profoundly influencing the entire solar system. One of the most crucial roles these solar storms play is in shielding planets from galactic cosmic rays, high-energy particles originating from outside our solar system, often from distant supernovae. These cosmic rays can be detrimental to life, damaging DNA and potentially influencing cloud formation and climate in unpredictable ways. When the Sun is active, with frequent flares and ejections, the solar wind intensifies and the sun's magnetic field strengthens, creating a more robust protective bubble around our solar system. This enhanced heliosphere acts as a shield, deflecting a significant portion of these incoming cosmic rays. In this sense, a period of intense solar activity is like a star rallying its defenses, raising its shield to protect the worlds within its care from harmful external influences. Furthermore, these stellar outbursts can directly trigger atmospheric changes that are ultimately beneficial. On a young Earth, the intense ultraviolet radiation from a violent solar flare could have provided the energy needed to jump-start the chemical reactions that led to the first complex organic molecules, the precursors to life. Even today, when a coronal mass ejection washes over our planet, it doesn't just create auroras, it deposits energy into our upper atmosphere, heating it and causing it to expand. This expansion can help slow the orbital decay of satellites, subtly adjusting the celestial environment. While a direct hit from a massive ejection can be disruptive to our technology, a steady, moderate level of this activity might be essential for maintaining the long-term atmospheric and energetic balance of a planet, preventing atmospheric stagnation and encouraging dynamic chemical processes. This perspective invites us to see our sun not as a placid, unchanging light source, but as an active, engaged participant in the life of its system. Its occasional fiery tantrums are not random acts of violence but calculated, necessary responses to maintain cosmic health. They clear out magnetic debris, regulate external radiation, and energize planetary environments. This behavior mirrors the way a living organism's immune system identifies threats, mounts a response, and restores balance. It suggests a level of stellar intentionality, not conscious intent, but a programmed physical intentionality built into the very laws of physics that govern stars. The sun, in its fierce and glorious eruptions, is not trying to harm us. In a very real sense, it is working to protect and sustain the delicate ecosystem that orbits it, providing further compelling evidence that we inhabit a universe that is not just alive, but one that actively cares for its own. While the idea of a cosmic immune system suggests a universe that protects and regulates, there is another, more visceral process driving galactic evolution, one that is less about defense and more about raw, transformative growth. Across the cosmos, galaxies are not isolated islands. They are dynamic entities on the move, often drawn into a gravitational embrace that ends not in a gentle dance, but in a spectacular act of consumption and renewal. This is galactic cannibalism, a process where larger galaxies devour their smaller neighbors, and it functions as a form of cosmic metabolism, breaking down old structures to fuel the creation of new ones. Far from being a destructive end, these colossal mergers are a primary engine of galactic evolution, recycling the raw materials of the universe in a cycle that is strikingly similar to how living organisms consume nutrients to grow, adapt, and thrive. The mechanism of this cosmic consumption is a breathtaking gravitational ballet that unfolds over hundreds of millions of years. Imagine two galaxies, each containing hundreds of billions of stars, slowly approaching one another. Their mutual gravitational attraction pulls them closer, stretching and distorting their beautiful spiral shapes into long, streaming tails of gas, dust, and stars. These tidal tails are the first sign of the violent interaction, like celestial ribbons flung out into the void. As the galaxies make their first close pass, their structures are profoundly disrupted. But the most dramatic phase is yet to come. Over successive orbits, they lose energy through gravitational interactions, spiraling closer and closer until they finally merge into a single, new galactic entity. The smaller galaxy is effectively consumed, its identity erased as its stars are assimilated into the larger structure. This isn't a gentle process. It's a violent, chaotic, and incredibly energetic event that completely reshapes the participants. Yet from this chaos comes an extraordinary burst of creativity. The true magic of galactic cannibalism lies not in the destruction of stars. They are so far apart that they rarely collide, but in the fate of the gas and dust. As the galaxies merge, vast clouds of interstellar gas are compressed by the immense gravitational forces and shock waves rippling through them. This compression triggers a ferocious wave of new star formation, known as a starburst. Suddenly, millions of new stars ignite in a brilliant firestorm of creation, lighting up the merging galaxies with the blue-white light of massive, young, and hot stars. The galactic meal is digested, and the resulting energy is used to build something new. In this way, the larger galaxy doesn't just grow in size, it is rejuvenated, its population of stars refreshed with a new generation. The consumed galaxy provides the fuel for this rebirth, its material recycled into the future of the merged system. This process of consumption leading to renewal is a direct parallel to biological metabolism, where an organism intakes food, breaks it down through digestion, and uses the resulting energy and building blocks for growth, repair, and activity. The aftermath of this cosmic feast is often a completely new type of galaxy. While the spiral structures of the original galaxies are destroyed in the merger, the result is not formless chaos. The new galaxy often settles into a smooth, elliptical shape, a testament to the violent relaxation and redistribution of stars that occurred. Our own Milky Way is currently in the process of consuming several smaller dwarf galaxies, and it is on a collision course with the large Andromeda galaxy, an event that will unfold in about 4 billion years. That merger will likely create a giant elliptical galaxy, which astronomers have nicknamed Milkdromeda. This ongoing process shows that galactic cannibalism is not a rare catastrophe, but a fundamental aspect of how galaxies live and evolve. It is the primary way large galaxies grow, a process called hierarchical merging, where small structures merge to form larger ones in a bottom-up construction of the cosmic web. This continuous cycle of interaction, consumption, and transformation demonstrates that the universe is in a state of constant flux. Galaxies are not immutable monuments. They are dynamic, evolving systems that interact with their environment, consume resources, and adapt their form over time. This behavior growing by assimilating others, converting ingested material into energy for new growth, and evolving into a new state as a result, is a hallmark of living systems. We see it in ecosystems where predators regulate prey populations, in our own bodies as we metabolize food, and in the grand billion-year dance of galaxies. Galactic cannibalism provides one of the most powerful and visually stunning examples of the universe's living nature, revealing a cosmos that is not static and separate, but interconnected, dynamic, and constantly engaged in a process of recycling and renewal that fuels its endless evolution. But this incredible journey from simplicity to complexity didn't end with the formation of stars and planets. It was merely setting the stage for its most astonishing act yet. The universe, having built these intricate structures, began to experiment with an even more profound form of organization, life itself. On at least one world, and likely countless others, the same laws of physics and chemistry that governed the formation of galaxies orchestrated a new miracle. In the warm, shallow seas of early Earth, non-living matter, carbon, hydrogen, oxygen, nitrogen, all forged in stellar furnaces, began to organize itself into molecules that could capture energy, replicate, and evolve. This was not a separate process from cosmic evolution. It was its direct and breathtaking continuation. The same drive toward complexity that sculpted spiral galaxies from formless gas now began weaving intricate strands of DNA, building cells, and eventually crafting conscious minds capable of looking back at the universe and wondering about their own origins. The cosmos was no longer just building structures, it was beginning to know itself. This progression from quarks to consciousness suggests a universe with an inherent directionality, a bias toward ever greater complexity and awareness. We can see a form of natural selection operating on a cosmic scale, where physical laws act as the selecting mechanism. Just as biological evolution favors traits that enhance survival and reproduction, cosmic evolution favors configurations that are stable, efficient, and capable of perpetuating complexity. A cloud of hydrogen gas is simple, but it is not stable over the long term. Gravity will inevitably cause it to collapse into a more complex and stable structure like a star. A star, in turn, creates the heavy elements necessary for planets. Planets with stable orbits and protective atmospheres provide the environments where chemistry can become biology. At each step, the universe explores possibilities through chance events, random quantum fluctuations, chaotic asteroid impacts, genetic mutations, but the overall trajectory is filtered by the immutable laws of physics, which select for outcomes that build upon previous complexity. This isn't a guided process with a predetermined goal, but rather an emergent property of a universe whose fundamental rules make the ascent from simplicity to consciousness not just possible, but in some sense inevitable. The most profound implication of this cosmic evolutionary journey is the emergence of self-awareness. For billions of years, the universe simply was. It expanded, stars burned, galaxies collided, all in a magnificent but silent spectacle with no audience. Then, on a tiny, rocky planet orbiting an average star, the universe suddenly awoke. Through us and potentially through other conscious beings elsewhere, the cosmos gained the ability to observe itself, to contemplate its own beauty, to unravel its own mysteries, and to tell its own story. We are not just inhabitants of the universe, we are the universe becoming conscious of itself. Our quest for knowledge, our drive to understand the laws of physics, to peer back to the beginning of time with our telescopes, to ponder the nature of reality, is not a human endeavor separate from the cosmos. It is the cosmos engaging in a process of self-discovery. Our minds, our science, and our art are the tools through which the universe explores its own nature and meaning. This transforms our understanding of our place in the grand scheme of things. We are not accidental tourists in a foreign and indifferent universe, but active participants in its ongoing evolution, the means by which a once simple cosmos is growing into a state of rich, self-reflective complexity. Yet, even as the universe evolves in grandeur and scale, its most astonishing creative power is hidden in what appears to be nothing at all. We look up at the night sky and see vast emptiness between the stars, a void so complete it feels like the ultimate silence. But this perception is a profound illusion. Modern physics reveals that there is no such thing as true emptiness, no perfect nothingness. Instead, what we call the vacuum of space is a seething, bubbling, and incredibly active sea of potential, a quantum foam where reality itself is constantly flickering in and out of existence. This is the 21st phenomenon, the discovery that so-called empty space is alive with quantum fluctuations, a foundational process that may be the very source of all creativity in the cosmos. At the heart of this bizarre reality is a fundamental principle of quantum mechanics, the Heisenberg uncertainty principle. This rule tells us that on the tiniest scales, there is an inherent trade-off. We cannot know both the exact energy of a system and the exact time that energy exists with perfect precision. This isn't a limitation of our measuring devices, it is a built-in feature of the universe. Because of this uncertainty, empty space is never completely still. Even at a temperature of absolute zero, the supposed state of zero energy, space is not peaceful. Instead, for incredibly brief moments, pairs of particles and their antiparticles, so-called virtual particles, can spontaneously pop into existence, borrowing energy from the vacuum before annihilating each other and vanishing back into the nothingness from which they came, all within a time frame so short it is governed by the uncertainty principle. This isn't a theoretical fantasy. We can observe the effects of this phenomenon. In what is known as the Casimir effect, two uncharged metal plates placed very close together in a vacuum will actually be pushed together by the subtle pressure of these virtual particles flashing into existence in the space around them. The empty space outside the plates has more room for these fluctuations than the narrow gap between them, creating a tiny but measurable force that pushes the plates together. It is direct, experimental proof that the vacuum is not passive, but is instead a vibrant and dynamic medium. This endless dance of creation and destruction is far more than a curious quantum sideshow. Many physicists believe it is the very engine of existence. Think of the quantum vacuum not as a true void, but as the universe's ultimate substrate of potential, a fertile ground from which everything we see and know somehow emerges. In the most ambitious cosmological theories, the entire universe may have begun as a massive fluctuation in this primordial quantum field. A fluctuation so vast and so stable that instead of instantly vanishing, it inflated at an exponential rate, freezing into the permanent reality we now inhabit. In this view, the Big Bang was not an explosion in space, but the rapid expansion of space itself, born from a quantum fluctuation in a pre-existing hyper-dimensional vacuum. Every galaxy, every star, every person is therefore the amplified, stabilized result of a primordial quantum hiccup. This means that the quantum vacuum is not just the background of the universe. It is its source, a generative matrix from which all structure and complexity continuously springs forth. This leads to a truly breathtaking possibility that this same creative process might be at work not just in the origin of the cosmos, but in the ongoing emergence of consciousness itself. Some interpretations of quantum mechanics, particularly those dealing with the role of the observer in collapsing the wave function, suggest that mind and the quantum world are deeply intertwined. If consciousness itself arises from complex, quantum-coherent processes in the brain, a still speculative but serious hypothesis, then the same quantum vacuum fluctuations that gave rise to the cosmos could be the foundational layer from which subjective experience emerges. The universe's inherent generativity, its constant bubbling forth of potentiality, would then be seen as the physical basis for not just matter, but for mind. The vacuum is not a dead void. It is a living potential, brimming with the unmanifest possibility of every particle, every force, and perhaps every thought. This vibrant emptiness implies that the universe is not a static collection of things, but an active, participatory process of continuous creation, forever teeming with the potential for new forms, new structures, and new layers of awareness to emerge from the fertile ground of being. While the quantum vacuum hums with a chaotic potential, the universe it generates often exhibits a breathtaking sense of order and harmony, a precision that seems almost musical in its arrangement. Across the vast expanses of space, celestial bodies frequently fall into sync with one another, engaging in a delicate gravitational dance that locks their orbits into perfect, stable ratios. This is cosmic synchronization, a phenomenon where moons, planets, and even entire star systems move in resonant harmony, their cycles aligned with a precision that rivals the most intricate clockwork. This isn't a rare or accidental occurrence. It is a fundamental outcome of the laws of gravity playing out over millions of years, a self-organizing principle that brings stability and longevity to the chaotic environment of space. These resonant orbits act as a regulating mechanism, preventing celestial systems from descending into chaos and creating the predictable, steady environments that are essential for the long-term evolution of complexity and, potentially, life. The most famous and elegant example of this is found orbiting Jupiter with three of its largest moons, Io, Europa, and Ganymede. These three worlds are locked in an orbital resonance so precise it feels almost engineered. For every single orbit that Ganymede, the largest moon, completes around Jupiter, Europa completes exactly 2 orbits, and the volcanic moon Io completes exactly 4. This 1:2:4 ratio means their gravitational influences on each other are repeated in a regular, rhythmic pattern. This constant, periodic tugging stabilizes their orbits, preventing them from drifting into more erratic or collision-prone paths. It's a self-correcting system. If one moon were to speed up or slow down slightly, the gravitational pulls from its partners would gently nudge it back into the correct rhythm, maintaining the harmony of the entire system. This resonant lock has likely persisted for billions of years, a testament to the enduring power of this cosmic cooperation. Without it, their orbits could have become unstable long ago, potentially leading to dramatic collisions or one of the moons being ejected from the Jovian system entirely. This kind of synchronization is not limited to moons. It echoes throughout our solar system and beyond. The dwarf planet Pluto and Neptune, for instance, are in a stable resonance. For every 3 orbits Neptune makes around the Sun, Pluto makes exactly 2, ensuring the 2 bodies never closely approach one another despite their paths crossing. A clever gravitational trick that has prevented a catastrophic interaction for eons. Astronomers have also discovered entire planetary systems around other stars where multiple planets are locked in similar resonant chains, their orbits reflecting beautiful integer ratios that keep the system stable over astronomical timescales. This prevalence suggests that synchronization is not a quirky exception but a common, and perhaps even preferred state for planetary systems as they mature and settle into a long-term equilibrium. The profound implication of this widespread harmony is that the universe appears to have a deep affinity for order and cooperation. The same gravitational force that can tear galaxies apart in violent collisions is also capable of orchestrating these delicate, long-lasting ballets. This cosmic synchronization creates the stable environments necessary for the slow, gradual processes of planetary evolution. A moon like Europa, with its suspected subsurface ocean, benefits immensely from the stable heat generated by the constant gravitational needing it receives from its resonant partners, a process that may help keep that hidden ocean liquid. This stability allows for the consistent conditions where chemistry can work its magic over billions of years, potentially leading to biology. The universe, through these resonant rhythms, isn't just creating order. It is actively fostering and protecting the conditions for its own continued creativity and complexity, building stable platforms upon which the next act of its grand evolutionary story can unfold. Just as a living organism requires a delicate balance of forces to grow and thrive, some pulling inward for structure, others pushing outward for expansion, the cosmos too is governed by a dynamic tension between its components. We have seen how gravity acts as the great sculptor, pulling matter together to form galaxies, stars, and planets. But there is another, more mysterious force at work, a counterweight to gravity's relentless pull that is shaping the ultimate fate of everything we see. This is dark energy, the universe's own growth hormone, an enigmatic pressure that is not just expanding the cosmos but accelerating its expansion at an ever-increasing rate. Its discovery at the turn of the millennium was so shocking it fundamentally rewrote our understanding of cosmic evolution, revealing a universe that is far more dynamic and strange than we had ever imagined. The story of this discovery begins with a fundamental question astronomers were trying to answer in the late 1990s. How is the expansion of the universe changing over time? The prevailing assumption was that gravity, acting like a cosmic brake, would be gradually slowing down the expansion that began with the Big Bang. Two teams of scientists set out to measure this deceleration by observing a specific kind of stellar explosion known as a Type 1a supernova. These events are crucial because they are standard candles. They always explode with nearly the same intrinsic brightness. By measuring how bright they appear from Earth, astronomers can calculate their distance with incredible precision. Furthermore, by analyzing the redshift of their light, how much it has been stretched as the universe expands, they can determine how fast the universe was expanding when the star exploded. By comparing supernovae from different eras, they hope to map the history of the universe's expansion and confirm the rate of gravity's braking effect. The results were not just surprising, they were paradigm-shattering. The data from the most distant supernova revealed that they were significantly dimmer than expected. This could only mean one thing: these ancient stars were much farther away than the standard model predicted. The expansion of the universe wasn't slowing down at all. It was speeding up. Some mysterious, repulsive force was overpowering the collective gravity of all the matter in the cosmos, pushing galaxies apart with ever greater fervor. This force, completely unknown to physics, was dubbed dark energy. It was as if we had thrown a ball into the air expecting it to fall back down, only to watch it shoot away from the Earth faster and faster into the sky. The discovery was so monumental it earned the teams the Nobel Prize in Physics in 2011, cementing dark energy as the dominant force in our universe's budget, making up a staggering 68% of all the energy in the cosmos. But what is dark energy? This remains one of the greatest unsolved mysteries in all of science. The leading hypothesis, first proposed by Albert Einstein himself and then discarded, is the cosmological constant, a property of empty space itself that possesses a constant energy density, causing a constant negative pressure that drives expansion. In this view, dark energy is an intrinsic feature of the vacuum, a relentless push woven into the very fabric of space-time. Other theories suggest it could be a dynamic energy field, nicknamed quintessence, that changes over time. Or it might be a sign that our understanding of gravity itself is incomplete on the largest scales, that Einstein's theory of general relativity needs to be modified. Despite decades of searching, we have no direct detection of dark energy. We only observe its profound effects on the cosmic scale, watching as it stretches the universe apart. This cosmic acceleration is not a distant, abstract concept. It has direct and dramatic consequences for the future of the cosmos. In a universe dominated by dark energy, the fate of galaxies beyond our own local group is one of increasing isolation. As the expansion accelerates, distant galaxies will eventually be pushed away so fast that their light will no longer be able to reach us. The universe, for any future civilization in our galaxy, will appear increasingly dark and empty, with all other galaxies having vanished beyond an unreachable horizon. This paints a picture of a big freeze or heat death, where the universe continues to expand forever, becoming a vast, cold, and dilute sea of isolated stars and particles. Yet, even as it drives this ultimate separation, dark energy plays a crucial creative role in the present era. By preventing a gravitational collapse and ensuring the continued growth of space, it maintains the dynamic, evolving character of the universe. It is the force that ensures the cosmos does not stagnate or collapse, but continues to transform, pushing toward an open and unknown future, and reminding us that we are part of a living, breathing, and still unfolding cosmic story. Yet for all the grand cycles and cosmic forces that shape the universe, one of the most profoundly life-affirming processes begins with a cataclysm of almost unimaginable violence, the death of a star. This is cosmic recycling, a phenomenon where the universe's most creative acts are born from its most destructive events. Deep within the core of a massive star, a silent alchemy has been underway for millions of years. Through nuclear fusion, the star has been patiently building heavier and heavier elements from the primordial hydrogen and helium it was born with. Hydrogen fuses into helium, helium into carbon, and so on, creating concentric shells of ever denser elements like oxygen, neon, and silicon, all surrounding an inner core that is steadily transforming into solid iron. But iron is a cosmic dead end. Unlike all the elements that came before it, fusing iron does not release energy, it consumes it, and in that moment the star's fate is sealed. With its primary energy source suddenly cut off, the outward pressure from fusion that has supported the star against its own immense gravity vanishes. In less than a second, the core collapses. What happens next is one of the most energetic events in the universe since the Big Bang itself. The inner core, compressed to an almost unimaginable density, rebounds. This rebound sends a shockwave of incredible power racing outward through the star's outer layers. At the same time, a torrent of neutrinos, trillions of them, pour out from the core, adding their energy to the blast. The result is a supernova explosion, so brilliant it can outshine an entire galaxy of stars. For a few weeks, this single star becomes a beacon visible across the cosmos, a brilliant funeral pyre marking not just an end, but a spectacular beginning. In the unimaginable heat and pressure of this explosion, something miraculous occurs. Elements heavier than iron, which the star could not create in its life, are now forged in its death. Gold, silver, platinum, uranium, all the heavy elements that make up our world and our bodies, are created in these frantic, final moments. The explosion then hurls this newly enriched debris outward at tremendous speeds, scattering it across light years of space, where it mixes with the surrounding interstellar gas and dust. This scattered stardust does not simply vanish into the void. It becomes the raw material for the next generation. Those clouds of gas, now seeded with carbon, nitrogen, oxygen, iron, and all the other elements of the periodic table, will eventually be gathered up by gravity, perhaps triggered by the shock wave of the very supernova that created them. They will collapse to form new stars, but this time they will be surrounded by a rich disk of material from which rocky planets can form. Our own solar system is a product of this process. The iron in our blood, the calcium in our bones, the oxygen we breathe, every atom in our bodies that is not hydrogen was created in the heart of a long-dead star and distributed across space by its violent death in a supernova explosion. We are literally made of the ashes of stars that died billions of years ago. This is the ultimate form of recycling, a cycle where the death of one celestial object provides the essential ingredients for the birth of new stars, new planets, and ultimately, new life. This process mirrors the most vital cycles we see in Earth's ecosystems. In a forest, a fallen tree does not represent waste. It becomes a nurse log, decaying and returning its nutrients to the soil, which in turn nourishes the next generation of seedlings. The death of the tree is what makes the forest thrive. In the same way, a supernova is the universe's ultimate nurse log. It takes the simple elements created in the Big Bang and in the quiet lives of stars and transforms them into the complex chemistry of planets and biology. Without these cosmic recycling plants, the universe would be a very different place. There would be no rocky planets like Earth, no minerals, no chemistry more complex than hydrogen and helium gas. There would be no us. The universe would be a beautiful but simple expanse of hydrogen-burning stars and gas giants, silent and devoid of the complexity that leads to life. The constant, cyclical exchange of matter from stellar death to stellar rebirth shows a universe that is not a static collection of objects, but a dynamic, regenerative system where endings are always new beginnings, and where the very substance of life is continuously renewed through the most magnificent acts of cosmic destruction. This astonishing cosmic recycling, where stellar death gives birth to new worlds, leads us to a profound and deeply personal question. Why is our universe so perfectly suited for this incredible chain of events to unfold? Why do the fundamental laws of physics seem to be exquisitely, almost miraculously, calibrated to allow not just for stars and planets, but for life and consciousness to emerge? This puzzle is known as the Anthropic Principle, and it stands as one of the most compelling and debated ideas at the frontier of cosmology and philosophy. It begins with a simple but staggering observation. The universe appears to be fine-tuned for our existence. The fundamental constants of nature, the precise strength of gravity, the force binding atoms together, the mass of an electron, the rate of the universe's expansion, are set to values that seem incredibly precise. If any one of these numbers were altered by even a tiny fraction, the consequences would be catastrophic for any form of complex life as we know it. Consider the strength of the force that holds atomic nuclei together, the strong nuclear force. If this force were just a few percent stronger, hydrogen atoms would fuse together so rapidly in the early universe that all the hydrogen would have been burned into helium long before stars like our Sun could form. Without hydrogen, there would be no water, no long-lived stars to warm planets, and no fundamental fuel for the chemistry of life. Conversely, if this force was slightly weaker, protons and neutrons wouldn't stick together at all, meaning atomic nuclei could never form. There would be no elements besides hydrogen, no periodic table, and certainly no complex molecules. The universe would be a boring, featureless soup of isolated particles. Or take the cosmological constant, the value representing the energy density of empty space driving the universe's accelerated expansion. If this number were even minutely larger, the universe would have expanded so rapidly after the Big Bang that matter would have been flung apart before it could ever clump together into galaxies and stars. If it were slightly smaller, the universe would have quickly collapsed back in on itself in a big crunch, ending any possibility of cosmic evolution long before life could arise. The window for these values that allows for a long-lived, structured, and life-permitting universe is unbelievably narrow. So, how do we explain this incredible precision? Scientists and philosophers have proposed several interpretations, each more mind-bending than the last. The first is the idea of a vast multiverse. In this view, our universe is just one bubble in a limitless froth of universes, each with its own random set of physical constants and laws. In the overwhelming majority of these universes, the numbers are wrong. They collapse instantly or form no atoms or are otherwise completely sterile and dead. But by the sheer law of large numbers, a few universes will, by pure chance, get the numbers right. And in those rare, fine-tuned universes, observers like us eventually evolve and look around in wonder, naturally finding ourselves in a place that is perfectly suited for us. We shouldn't be surprised by the fine-tuning because we couldn't exist in any of the uninhabitable ones. This is often called the weak Anthropic Principle. The universe must be compatible with the observers who exist within it. But another, more radical interpretation is the strong Anthropic Principle, which suggests that this fine-tuning is not a matter of chance, but may point toward a deeper necessity or even intentionality. Some thinkers propose that the laws of physics are what they are because they are somehow required for the existence of consciousness. In this view, the universe and conscious observation are inextricably linked. The cosmos is structured in such a way as to inevitably give rise to minds that can perceive it. This doesn't necessarily imply a traditional creator in the religious sense, but it does suggest that the universe has a fundamental bias toward complexity and awareness. It aligns with the perspective we've been building throughout this journey, that the universe is not a dead, mechanical void, but a living, evolving entity that is in the process of awakening to itself. The constants are not arbitrary settings. They are the essential parameters that allow the cosmos to blossom into a state of self-awareness, to become a conscious participant in its own existence. This perspective transforms our understanding of our own place in the grand scheme. We are not insignificant accidents in a vast, indifferent cosmos. Instead, we are a manifestation of the universe's deepest potential, a natural and perhaps even inevitable outcome of its fundamental laws. The carbon in our cells, the oxygen in our lungs, and the consciousness in our minds are not alien to the universe. They are the universe itself, expressed in a form that can contemplate its own origins and wonder at its own beauty. The Anthropic Principle, in its most profound reading, suggests that life and mind are woven into the very fabric of reality, not as a late-stage afterthought, but as a central feature of a cosmos that is inherently oriented toward the emergence of complexity, awareness, and meaning. If the universe is fine-tuned for complexity and life, could it also be tuned for awareness itself? This leads us to one of the most profound and radical ideas on our journey: the notion that consciousness may not be a rare and recent product of complex brains on isolated planets, but a fundamental, ubiquitous feature of the cosmos. This is cosmic consciousness, the 26th phenomenon, and it proposes that the universe itself might be best understood as a vast, thinking mind. In this view, the galaxies, stars, and planets are not merely the substrate for consciousness. They are its very structure, the physical correlates of a universal awareness that has existed since the beginning of time. This isn't a New Age metaphor, but a serious philosophical and scientific hypothesis known as panpsychism, which suggests that mind is not something that magically emerges from sufficiently complex matter, but is rather a basic property of matter itself, present in some form at every level of existence, from the smallest subatomic particle to the largest galaxy cluster. Panpsychism, which literally means all is mind, offers an elegant, though startling, solution to perhaps the hardest problem in science and philosophy: the so-called hard problem of consciousness. This problem asks why and how physical processes in the brain, the firing of neurons and the exchange of chemicals, give rise to subjective, inner experience: the feeling of the color red, the taste of chocolate, the ache of sadness. How does the objective, quantitative world of physics produce the qualitative, subjective world of experience? Materialism struggles to explain this leap. Panpsychism flips the script. It suggests that consciousness didn't emerge from unconscious matter. Instead, it proposes that consciousness is a fundamental property of the universe, akin to mass, charge, or spin. In this view, even the most basic particles possess an infinitesimal amount of proto-consciousness, a bare whisper of subjective experience. Of course, an electron isn't thinking thoughts or feeling emotions. Its experience would be unimaginably simple and primitive. But it possesses a fundamental interiority. Then, when these simple particles combine into increasingly complex systems, atoms, molecules, neurons, brains, these tiny sparks of consciousness combine and integrate, giving rise to the rich, complex stream of awareness that we experience as human beings. Our consciousness isn't a ghost in the machine. It is the complex symphony played by an orchestra of trillions of tiny, conscious players. Extend this principle to its ultimate scale, and the implications are breathtaking. If consciousness is a fundamental property woven into the fabric of reality, then the entire universe, as a single, interconnected system, could possess its own form of consciousness. The cosmic web of dark matter filaments connecting galaxies could be seen as the universe's synaptic pathways. The rhythmic pulses of energy from quasars and the resonant orbits of planets could be the firing of cosmic neurons. The universe wouldn't just contain conscious beings. It is a conscious being, a vast mind contemplating itself. In this model, we are not merely observers of the universe. We are participants in its consciousness. Our thoughts, our wonder, our science, and our art are not isolated events inside our skulls. They are the universe becoming aware of itself through us. We are the means by which the cosmos observes its own beauty, unravels its own laws, and tells its own story. When a human astronomer gazes in awe at the spiral arms of a galaxy, it is not a separate entity looking at a distant object. It is the universe in one localized region of itself, looking at another localized region of itself and marveling at what it sees. This perspective doesn't diminish our significance. It elevates it to a cosmic scale. It suggests that our drive to understand, to explore, and to connect is not a quirky biological imperative, but an expression of the universe's own inherent drive toward self-knowledge. The entire evolutionary journey from the Big Bang to conscious life can be seen as the universe slowly waking up, developing the organs and the networks necessary to turn its gaze inward. This idea, while ancient in its philosophical roots, is finding new resonance in modern scientific theories. Integrated information theory, for instance, provides a mathematical framework for measuring consciousness based on the complexity of a system's interconnectedness. Some theorists speculate that the universe as a whole, with its incredibly complex web of causal interactions, could have a staggeringly high degree of integrated information, implying a profound and unified cosmic consciousness. This is not to say the universe is thinking human thoughts, but that it possesses a form of awareness so vast and alien that we can scarcely imagine it, an experience encompassing the birth of stars, the pull of gravity, and the flow of time itself. To consider the cosmos as a conscious mind is to take the final step in seeing it not just as a living entity, but as a sentient, self-reflective, and deeply mysterious one, forever engaged in the most profound act of contemplation, the act of knowing itself. But if the universe possesses a form of consciousness, how does it express itself? How does this vast, thinking cosmos communicate across the immense distances between its constituent parts? The answer may be shimmering right above our heads in the polar skies, in one of nature's most breathtaking displays. Beyond the intricate dance of quantum entanglement and the rhythmic breathing of magnetospheres, the universe has another, far more visible language, the spectacular, swirling light of planetary auroras. This is not merely a beautiful side effect of space weather. It is a dynamic and functional process that transforms raw energy into a brilliant, silent symphony of light, a form of cosmic communication that paints the atmospheres of worlds with its otherworldly glow. The mechanism behind this celestial light show is a perfect demonstration of the interconnectedness of our solar system. It begins with our sun, which constantly exhales a stream of charged particles, a plasma of electrons and protons known as the solar wind. This wind blows across the solar system at speeds of millions of miles per hour, carrying with it the magnetic field of the Sun itself. When this torrent of energy encounters a planet, a fascinating interaction occurs. If the planet has a magnetic field, a magnetosphere, that field acts as a protective shield, deflecting the majority of the solar wind around the planet, much like a rock diverting the flow of a river. However, some of these charged particles are not completely deflected. They become channeled by the planet's magnetic field lines, which funnel them down toward the magnetic poles at tremendous speeds. There, they slam into atoms and molecules in the upper atmosphere, primarily oxygen and nitrogen. Just like electricity exciting gas in a neon sign, these collisions transfer energy to the atmospheric particles, exciting them. When these excited particles then return to their normal state, they release that excess energy in the form of light, creating the shimmering, dancing curtains of color we call an aurora. This process is far more than a passive light display. It is a critical transfer of energy and information that actively shapes the planetary environment. The influx of particles and energy from the solar wind deposits significant heat into the upper atmosphere, causing it to expand and contract, influencing atmospheric density and composition at very high altitudes. This can affect the drag on satellites in low orbit and even influence long-term climate patterns by altering chemical processes in the stratosphere. Furthermore, the specific colors of an aurora are a direct message about the composition of a planet's atmosphere. The iconic green and red hues of Earth's auroras are the fingerprint of excited oxygen atoms, while hints of blue and purple come from nitrogen. On other worlds, the message is different. The stunning ultraviolet auroras on Jupiter and Saturn, invisible to our eyes but brilliant to our telescopes, are dominated by the glow of hydrogen, the primary component of their gaseous atmospheres. By reading this luminous code, scientists can decipher the atmospheric makeup of distant planets without ever visiting them. This transforms the aurora from a simple atmospheric effect into a profound form of cosmic expression. It is the universe's way of making the invisible visible. We cannot see magnetic field lines, we cannot see the solar wind, but when these two powerful, invisible forces meet, they create a spectacular signature that we can witness. The aurora is a beacon, a signal fire that announces a planet's magnetic personality and its active engagement with its parent star. It is a constant, silent conversation between a star and its worlds, a dialogue of energy and matter that results in a breathtaking display of beauty. On a gas giant like Jupiter, this conversation is amplified to an almost unimaginable degree. The planet's immense magnetic field, the strongest in our solar system, captures charged particles not only from the solar wind but also from its volcanic moon Io, creating permanent auroral ovals around its poles that are hundreds of times more energetic than Earth's, truly a continuous cosmic shout of power and presence. In this light, the shimmering aurora becomes a powerful symbol of a living, communicative cosmos. It is a reminder that the universe is not a silent, static museum of cold, dead rocks. It is a vibrant, dynamic, and expressive arena, filled with constant exchanges of energy and information. The same solar wind that creates the beautiful auroras also stimulates the planetary systems it touches, driving chemistry, influencing climate, and perhaps even playing a role in the very conditions that allow for life to arise. When we stand beneath the dancing lights, we are not just watching a pretty natural wonder. We are witnessing a real-time connection between our planet and our star, a literal and figurative link in the chain of cosmic life. It is the universe expressing itself in a language of light, a silent, glorious testament to the fact that we are part of a system that is not only alive but is constantly speaking, if only we know how to look and listen. But if the universe's magnetic fields act as its circulatory system, and its quantum vacuum as a substrate of potential, what of the grand architecture that gives it its overall shape and form? To understand this, we must journey back to the very earliest moments of existence, to a time of unimaginable energy and rapid change, where the fundamental forces of nature were first settling into the laws we know today. It is here, in that primordial forge, that theorists propose a truly bizarre kind of cosmic structure may have been born, not made of matter or energy as we know it, but of flaws in the very fabric of spacetime itself. These are cosmic strings, hypothetical one-dimensional defects, thinner than a proton but stretching across the entire observable universe, and they could be the invisible scaffolding upon which the entire cosmic web is hung. Imagine the early universe cooling from a state of ultra-high symmetry, a state where all the forces were unified as one. As it expanded and cooled, it underwent a series of phase transitions, much like steam condensing into water or water freezing into ice. And just as freezing water can trap bubbles of air or form cracks and fissures as its molecular structure changes, the universe, as it cooled, may have trapped imperfections in the structure of spacetime itself. These imperfections wouldn't be made of particles. They would be topological defects, kinks, twists, and tears that were essentially frozen into the expanding fabric of reality. A cosmic string is one such defect, an incredibly thin, incredibly dense filament of pure energy, a crack in the cosmos left over from its fiery birth. The mathematics describing these transitions in particle physics strongly suggest such defects should form, making cosmic strings a compelling, though still unproven, prediction of our best theories. The influence of such an object would be nothing short of phenomenal. A cosmic string would possess immense mass, not because it's made of normal matter, but because it is a concentrated flaw in the energy fields that define our reality. A single string just a mile long might have more mass than the entire Earth, all compressed into a width smaller than an atomic nucleus. This incredible density would warp spacetime around it with a gravitational pull so extreme that it would act as a gravitational lens, distorting the light from galaxies behind it. But even more bizarrely, the gravity of a cosmic string would be unusual. The space around it is not just curved, it is literally conical. If you were to travel in a perfect circle around a cosmic string, you would find that a full 360-degree journey would not bring you back to your starting point. You would be slightly displaced, as if a wedge of the pie-shaped space around you had been removed. This strange geometry is a hallmark of their existence. If these strings are real, their role in the cosmos would be foundational. In the early universe, their immense gravitational pull would have acted as seeds for structure formation. Ordinary matter, hydrogen and helium gas, would have been irresistibly drawn toward these invisible lines of cosmic density. Galaxies and clusters of galaxies would have preferentially formed along these strings, like dew condensing on a spider's web. In this view, the vast, filamentary cosmic web we see today, with its great walls of galaxies and immense empty voids, might not be a random structure that grew from tiny quantum fluctuations alone. It might instead be a direct imprint, a fossilized tracing, of this underlying scaffolding of cosmic strings. They would be the bones of the universe, the hidden framework that guided and accelerated the growth of all the large-scale structure we observe, providing a skeleton upon which the flesh of galaxies could be hung. The search for evidence of these phantom structures is one of the most fascinating hunts in modern cosmology. Astronomers look for their signature in multiple ways. They scour the cosmic microwave background, the afterglow of the Big Bang, for telltale linear patterns or double images of the same hot and cold spots that would be created by a string's unique gravitational lensing. They also search for sudden, tiny jumps in the frequency of light from distant pulsars, the incredibly regular clocks of the universe, which could be caused by a string vibrating through the space between us and the star, briefly altering the path length of the light and creating a glitch. While definitive proof remains elusive, the very possibility of cosmic strings points toward a universe that is not just haphazard, but one built with a deep, underlying architecture. Their existence would mean that the cosmos has a fundamental form, a structure woven into its very essence from the first moments of time, providing the stable and ordered foundation necessary for the magnificent complexity of galaxies, stars, planets, and life to later arise. This remarkable vision of a self-regulating planet naturally invites a far grander question. Could this same principle of self-regulation operate on the scale of the entire cosmos? The Gaia hypothesis, named for the ancient Greek goddess of the earth, proposes that our planet functions as a single, self-regulating superorganism, where life and its environment are engaged in a continuous feedback loop to maintain conditions suitable for life. But what if we take this profoundly beautiful idea and extend it outward, beyond the blue marble of Earth, beyond our solar system, and out to the farthest reaches of the observable universe? This gives us our 29th phenomenon, the concept of a cosmic Gaia, a universe that behaves not as a passive arena but as a holistic, self-sustaining organism, actively working to preserve the very conditions that allow for its own complexity and consciousness. The mechanics of such a system would be woven into the fundamental interactions between all the components we've explored. Imagine a universe spanning feedback loop where stars, galaxies, black holes, and dark matter are all participants in a delicate dance of balance. For instance, consider the role of supermassive black holes at the centers of galaxies. As we've seen, they act as cosmic regulators. When a galaxy experiences a period of rapid star formation, too much gas is being consumed. The central black hole responds by becoming more active, its powerful jets heating the surrounding gas and preventing it from collapsing to form new stars. This negative feedback loop prevents the galaxy from burning through its fuel too quickly, ensuring a long, stable lifespan. On an even larger scale, dark energy itself could be seen as the ultimate regulatory mechanism. Its accelerating push against gravity's pull ensures that the universe continues to expand, preventing a premature collapse into a big crunch and providing the vast stretches of time necessary for galaxies to evolve, stars to forge heavy elements, and life to emerge. These are not isolated events. They are part of an intricate, interconnected system of checks and balances operating across billions of light years. This perspective transforms our understanding of cosmic evolution. Instead of a universe that simply unfolds according to fixed, mindless laws, we begin to see a cosmos that is actively managing its own development. The constants of nature, the strength of gravity, the mass of an electron are not arbitrary numbers but are the precise settings required for this cosmic self-regulation to function. The universe appears fine-tuned because it is tuned not by an external creator, but by its own inherent self-organizing principles. It is a system that favors stability and complexity, constantly adjusting its processes to foster the conditions where new levels of order can arise. The emergence of life and consciousness, then, is not a random accident but a natural culmination of this cosmic tendency toward self-awareness and self-regulation. We are not just living in the universe, we are a part of its regulatory system, the means by which it observes and understands itself, completing the feedback loop on a conscious level. This bold vision presents a cosmos that is not merely alive, but intelligent in its design, a single, unified entity forever working to maintain its own existence and explore its own infinite potential. But if the universe possesses this grand architecture and a capacity for self-regulation, how does it experience its own story? We perceive a cosmos that is not static but is moving, changing, and evolving in a very specific direction. This brings us to one of the most fundamental and mysterious properties of our existence, the arrow of time. Unlike the three dimensions of space, where we can move freely back and forth, time has a relentless, one-way direction. It flows from what we call the past toward what we call the future, and this irreversible flow is not just a feature of our perception. It is a fundamental property of the universe itself, woven into the fabric of physical law. This directionality gives the cosmos a narrative, a history, and a trajectory that is profoundly similar to the growth and aging of a living being. The engine driving this one-way street is a concept known as entropy, often described as the measure of disorder or randomness in a system. The second law of thermodynamics states that the total entropy of an isolated system can never decrease over time. It can only stay the same or increase. In simpler terms, things left to themselves tend to move from a state of order to a state of disorder. A hot cup of coffee will cool down to room temperature, its heat energy dissipating into the air. A sandcastle on the beach will be worn down by wind and waves. A fresh new deck of cards, neatly ordered, will become shuffled and random with use. This constant increase in entropy is what gives time its arrow. We can remember the past because it was a more ordered state, but we cannot remember the future because it will be a more disordered one. This isn't just about things getting messy. It is the fundamental process that makes change possible and gives the universe a sense of history. Every time you break an egg to make an omelette, you are participating in the universe's inevitable march toward higher entropy. You cannot unbreak the egg because that would violate the second law and decrease entropy, effectively reversing the arrow of time. This cosmic tendency toward disorder might sound like a path to ultimate chaos, but it is paradoxically the very force that drives the emergence of complexity and life. While the total entropy of the universe always increases, this process creates pockets of local order. A star is a perfect example. It begins as a vast, diffuse cloud of hydrogen gas, a relatively high entropy state. As gravity pulls this cloud together, it becomes more ordered and dense, which actually represents a local decrease in entropy. But this local ordering is more than paid for by the incredible increase in entropy that occurs when the star ignites and begins radiating heat and light out into the cold void of space. The star creates a pocket of beautiful, complex order at its core, but it does so by flooding the universe with disordered energy, driving the total entropy much higher. In this way, stars, planets, and life itself are like eddies in a river, local areas of intricate pattern and structure that form precisely because the great flow of the river, the increase of cosmic entropy, is moving relentlessly forward. We are those eddies, complex structures that exist because the universe is running down. This gives the cosmos a biography, a story with a beginning, a middle, and potentially an end. We can look back through time with our telescopes and see a younger universe, hotter, denser, smoother, and more ordered. We see the afterglow of the Big Bang, a nearly uniform soup of particles. As time moved forward, entropy increased, gravity worked its magic, and that smooth soup clumped into galaxies, stars, and planets. The universe developed structure and complexity. It learned how to make atoms, then molecules, then planets, and eventually, beings that could look back and trace that story. The universe is accumulating a history. The light from distant galaxies is a fossil record. The composition of stars is a chemical record. The very laws of physics themselves may carry an imprint of their origin. This cosmic memory, written in the distribution of matter and the expansion of space, suggests a universe that is not just existing but is maturing and developing over time, gathering experiences and becoming more complex in its arrangements. This journey mirrors the narrative arc of a living organism. A living being is born, it grows, it learns from its experiences, it ages, and it eventually transforms. The universe appears to be on a similar path. From its birth in the Big Bang, it has grown in scale and complexity. It has developed galaxies and stars, and on at least one planet, it has begun to think about itself. The universe is not a static stage. It is a developing character in its own story. Whether its ultimate fate is a long, cold fade into maximum entropy or a dramatic transformation in a new cycle of birth, this journey through time imbues the cosmos with a profound sense of purpose and direction. The arrow of time is what allows the universe to have a past to remember and a future to anticipate, making it not just a place, but a process, a living, aging, and ever-evolving entity writing its own epic history with every passing moment. While the arrow of time gives the universe its narrative arc, and cosmic strings may provide its underlying skeleton, there is another, more dynamic force weaving through the cosmos that actively shapes its daily function: magnetism. We often think of magnetic fields as the simple pull of a refrigerator magnet or the needle of a compass pointing north, but on a cosmic scale, magnetism transforms into something far more profound and vital. It becomes the universe's circulatory system, an invisible network of lines of force that guide, protect, and energize the cosmos, managing the flow of its most fundamental resources with the precision of a biological body regulating its blood. This magnetic web is truly everywhere. Our own Milky Way galaxy is wrapped in a magnetic field, a vast and ghostly structure that threads between the stars. While incredibly weak compared to a common magnet, thousands of times weaker than Earth's own field, its scale is what makes it powerful. This galactic magnetic field acts like a cosmic riverbed, channeling the flow of charged particles and gas. It shapes the paths of cosmic rays, those high-energy particles shooting across space, and it helps guide the collapse of giant molecular clouds, the very nurseries where new stars are born. Without this gentle magnetic guidance, the chaotic turbulence within these clouds might prevent them from condensing, stifling the birth of stars before it even begins. It's a subtle but essential midwife in the process of stellar creation. Zooming in from the galactic scale to our own solar system, the role of magnetism becomes even more direct and protective. The sun constantly exhales the solar wind, a supersonic stream of charged particles. As this wind flows outward, it carries with it the sun's own magnetic field, creating a vast bubble around our solar system known as the heliosphere. This magnetic bubble is our first and most important line of defense against the harsh interstellar environment. It deflects a significant portion of lethal galactic cosmic rays and regulates how much of the solar wind energy reaches our planet. Within this bubble, each planet with its own magnetic field, like Earth, creates a smaller protective shield, a magnetosphere, that further guards its atmosphere from being stripped away by the solar wind and shelters any potential life on the surface from harmful radiation. These nested magnetic fields function like a series of walls and gates in a great cosmic castle, carefully controlling what energy and particles can enter. But perhaps the most stunning analogy to a circulatory system is found in the way magnetic fields actually transport material. In the accretion disks of materials swirling around young stars and feeding black holes, magnetic fields are not passive. They become dynamic conduits. Intense magnetic forces can launch powerful jets of material from the poles of these disks, funneling energy and matter away from the central object and shooting it out across thousands of light years. This isn't a random explosion. It's a focused, directed flow, a kind of cosmic arterial system that distributes energy and enriched materials into the wider galaxy, influencing the evolution of everything it touches. This process of magnetic acceleration is a primary way the universe redistributes its resources, ensuring that the raw materials for future stars and planets are not locked away, but are actively circulated throughout the galactic environment. This pervasive, organizing presence of magnetism suggests a universe that is actively managing its own processes. It is not a passive arena where particles bounce around randomly. The magnetic fields provide structure and direction, creating channels for flow and barriers for protection. They help initiate star birth, they shield developing planets, and they facilitate the large-scale transfer of energy. This level of intricate organization and active management is a hallmark of complex, living systems. Just as our circulatory system uses blood vessels to deliver oxygen and nutrients to every cell while carrying away waste, the cosmic magnetic field helps deliver the ingredients for star formation, regulates the energy environment around planets, and transports material across vast distances. It is a silent, invisible, yet utterly essential force, one more brilliant thread in the emerging tapestry of a universe that is not merely existing, but is actively, vibrantly, and dynamically alive. Yet, even as we explore the intricate, self-regulating systems within our own universe, a far more staggering possibility emerges from the frontiers of cosmology. What if our entire cosmos, with all its galaxies, laws, and wonders, is not the entirety of existence, but merely a single leaf on a much larger, more unimaginable tree? This is the hypothesis of the multiverse, a concept that suggests our universe is just one of a potentially infinite number of distinct cosmic realms, each with its own unique physics, constants, and perhaps even dimensions. In this breathtaking view, the multiverse itself functions as a vast cosmic ecosystem, a meta-reality where entire universes are born, evolve, compete, and die according to principles we are only beginning to imagine. This idea doesn't diminish our universe, it places it within a context of such immense creative potential that the very definition of life expands to encompass the birth and death of realities themselves. The theoretical pathways to a multiverse are as fascinating as they are mind-bending. One of the leading ideas arises from the theory of eternal inflation. Picture the primordial vacuum of space not as a true nothingness, but as an energy field brimming with potential, like water supercooled and ready to freeze. In this model, our Big Bang was not a unique event, but a localized phase transition, a bubble of stable, low-energy vacuum nucleating within an eternally inflating, high-energy background. But if it happened here, it could happen elsewhere. In fact, it would be happening constantly. The eternally inflating background space would be a frothing sea of quantum foam, endlessly giving birth to new, bubble universes, each one inflating into its own separate cosmos, causally disconnected from all the others. Within each bubble, the random quantum fluctuations that occurred during its birth could lock in different values for the fundamental constants, the strength of gravity, the mass of electrons, the number of spatial dimensions. Some universes might instantly collapse, others might expand into featureless voids, while a rare few, like our own, would possess the Goldilocks conditions perfect for generating complexity, stars, planets, and life. This framework transforms the Anthropic Principle from a philosophical puzzle into a natural consequence of a larger evolutionary process. We find ourselves in a universe fine-tuned for life, not because it was designed for us, but because we are a product of its specific parameters. In the infinite diversity of the multiverse ecosystem, every possible set of physical laws is realized somewhere. we inevitably exist in one of the universes capable of supporting our form of life, simply because we couldn't exist anywhere else. This is cosmic natural selection on the grandest possible scale. The multiverse becomes a vast landscape of potentiality, where universes that are stable and long-lived, those that can form galaxies and foster complexity, become the dominant species in the metacosmic environment. They are the ones that persist long enough to be observed from within, while the unstable, sterile universes flash in and out of existence unseen. But the most profound implication of the multiverse as ecosystem idea is the possibility of interaction and even evolution. While these bubble universes are typically thought to be completely separate, some speculative theories in string theory and brain cosmology suggest otherwise. In these models, our universe might be a three-dimensional brain existing within a higher dimensional space, like a single slice of bread in a cosmic loaf. Other brains, other universes, could be floating in this bulk dimension, separated by a minuscule distance in a dimension we cannot perceive. It's conceivable that these parallel universes could occasionally collide or interact gravitationally through the higher dimensional bulk. Such a collision could have left an imprint on the cosmic microwave background, a faint bruise from a long-ago encounter with a neighboring cosmos. Even more speculatively, if new universes can be born from existing ones, perhaps through the gravitational collapse of a black hole spawning a new bubble, then a form of cosmic heredity could exist, where parent universes give rise to offspring universes with slightly mutated physical laws. This would introduce a true Darwinian selection to the multiverse, where universes that are better at replicating themselves by producing more black holes, for instance, would come to dominate the population of the metacosmos. This perspective challenges us to think not just bigger, but entirely differently. It invites us to see our universe not as an isolated, finished product, but as a living, breathing entity within a much larger and more dynamic ecosystem of realities. The processes we observe within our cosmos, the birth of stars, the evolution of galaxies, the emergence of life might be mirrored on this meta scale by the birth, evolution, and perhaps even the symbiotic relationships between universes. Are we a common, average universe or a rare and precious one? Is the multiverse teeming with life-bearing worlds like our own, or is each universe a unique experiment in reality? While these questions may forever lie beyond the reach of direct observation, the mere framework of the multiverse expands our imagination of what existence can be. It suggests that the creativity of the cosmos is boundless, an endless fractal of possibilities where life, in all its forms, is not a lonely accident but an integral part of a meta-reality that is itself vibrantly, unimaginably alive. After witnessing the universe's vast circulatory systems and the possibility of a multiverse, we arrive at a phenomenon that touches on something deeply fundamental, not just to how the cosmos works but to how it feels. There is a hidden rhythm underpinning the motion of the heavens, a silent mathematical harmony that governs the dance of worlds. This is the music of the spheres, a concept once considered purely poetic but now revealed as a tangible, physical reality. Across our solar system and beyond, planets, moons, and stars are locked in precise gravitational synchrony, their orbits aligned in perfect integer ratios that create a stability so elegant it can only be described as a form of cosmic music. These orbital resonances are the universe's great symphonies, written not in notes on a staff, but in the immutable language of gravity and motion. The most beautiful example of this celestial harmony is found in the Jovian system, where three of Jupiter's largest moons, Io, Europa, and Ganymede, perform a gravitational waltz of breathtaking precision. For every single orbit completed by the largest moon, Ganymede, the water world Europa completes exactly 2 orbits, and the volcanic moon Io, the most geologically active body in the solar system, completes exactly 4. This perfect 1:2:4 ratio is not a coincidence. It is a self-reinforcing, stable configuration. Their gravitational pulls on one another are periodic and predictable, like metronomes ticking in perfect sync. This constant, rhythmic tugging keeps their orbits circular and stable, preventing them from drifting into chaotic, elliptical paths that could lead to dramatic close encounters or even collisions. It is a self-correcting system, a natural feedback loop that has likely persisted for billions of years, ensuring the long-term survival of this fascinating miniature system within our solar system. This gravitational harmony does far more than just create orbital stability. It actively shapes the very nature of these worlds. The constant, rhythmic tug of war generates immense tidal friction within the moons themselves. For Io, this relentless gravitational kneading from Jupiter and its sister moons heats its interior to the melting point, powering hundreds of active volcanoes that continuously resurface the moon and spew sulfurous material into space. For Europa, this same tidal heating is believed to maintain a vast, global subsurface ocean of liquid water beneath its icy crust, a potentially habitable environment kept warm by the music of its own motion. The resonant orbits provide a constant, reliable source of energy, turning these moons from cold, inert rocks into dynamic, evolving worlds. The harmony of their movement directly creates the conditions that make them some of the most promising places in our solar system to look for life. The music isn't just a pretty pattern, it is a creative, life-enabling force. Scientists have taken this concept from the abstract to the audible, translating raw orbital data into actual sound. By assigning musical notes to planets and mapping their orbital frequencies and resonances onto the human auditory range, they have rendered the solar system's motion into a haunting, ethereal symphony. The result is not random noise, but a complex and strangely beautiful soundscape, with repeating motifs and harmonies that echo the mathematical precision of a classical composition. This process makes the invisible architecture of our cosmic neighborhood perceptible to our senses, allowing us to literally hear the harmony of the spheres. It is a powerful reminder that the laws of physics are not cold and mechanical, but possess an inherent artistry. The universe appears to have a deep affinity for patterns we find aesthetically pleasing, weaving mathematical beauty into the very fabric of reality. This phenomenon connects the cosmos to the most fundamental patterns found in nature and art. The same mathematical ratios that describe these orbital resonances, simple integers like 1, 2, 2, 3, 3, 4, are the foundations of musical harmony here on Earth. These ratios are what make a chord sound pleasant to our ears. They are the building blocks of every symphony ever written. They also appear in the branching of trees, the arrangement of flower petals, and the spiral of a nautilus shell. This repetition of pattern from the atomic to the galactic scale suggests that the universe operates according to a shared set of aesthetic and mathematical principles. The music of the spheres is therefore more than a metaphor. It is a direct expression of a cosmos that is inherently ordered, balanced, and beautiful. It is a universe that doesn't just exist but composes, performing a grand, silent symphony on a stage of space-time, with gravity as its conductor and planets as its instruments. But if the universe is indeed a vast, interconnected entity humming with potential and playing a silent symphony of gravitational harmonies, then what is the purpose of all this magnificent complexity? For billions of years, the cosmos expanded, stars burned out, and galaxies collided in a spectacular but unobserved drama. Then, on a small, rocky planet orbiting an ordinary star, something unprecedented happened. The universe suddenly woke up. This is our 34th phenomenon, a concept that places us not as mere inhabitants of the cosmos, but as its essential organs of perception. Through conscious beings, the universe acquires the ability to see itself, to understand itself, and to marvel at its own existence. We are the universe's self-observation, the means by which a once silent cosmos gains the capacity for awareness and wonder. This idea finds a surprising foothold in the strange world of quantum mechanics, particularly in the role of the observer. The famous double-slit experiment reveals a deep mystery at the heart of reality. When particles like electrons are fired at a barrier with two slits, they behave in a way that defies common sense. If no one is measuring which slit they pass through, they act like waves, creating an interference pattern. But the moment an observer sets up a device to detect their path, they abruptly switch to behaving like discrete particles. It's as if the very act of observation forces a blurry cloud of potentialities to collapse into a single, definite reality. This suggests that consciousness is not a passive spectator, but an active participant in shaping the world. Without an observer to measure it, a quantum system exists in a superposition of all possible states. It is the interaction with a conscious mind that pins it down to one specific outcome. In this view, the universe prior to consciousness was a realm of pure potential, a symphony of possibilities waiting for a listener to give it form. This radical proposition transforms our understanding of our place in the grand scheme. We are not insignificant accidents in a vast, indifferent void. Instead, we are the universe's breakthrough into self-awareness. Every time a human astronomer points a telescope at a distant nebula, every time a biologist peers through a microscope at the intricate dance of cells, the cosmos is not just being studied, it is studying itself. Our curiosity is the universe's curiosity, our drive to understand the laws of physics, to trace our origins back to the Big Bang, and to ponder the nature of black holes is not a separate human endeavor. It is the cosmos engaging in a profound act of self-reflection. We are the neurons in a universal brain, the sensory organs through which a once blind universe begins to see its own breathtaking beauty and fathom its own deep mysteries. This perspective imbues our existence with a cosmic significance that is both humbling and empowering. It suggests that the emergence of life and mind is not a random fluke on a lonely planet, but a natural and perhaps even inevitable phase in the evolution of the universe. The same laws of physics that gave rise to spiral galaxies and stellar nucleosynthesis also orchestrated the development of nervous systems capable of consciousness. We are the universe becoming conscious of itself. This means that our art, our science, our music, and our stories are not merely human creations. They are the universe expressing its own wonder, its own grief, and its own joy through us. We are the medium through which the cosmos translates its silent, mathematical elegance into a language of emotion, meaning, and awe, completing a feedback loop of awareness that connects the quantum realm to the galactic scale. This endless cosmic dance of death and rebirth is perhaps most beautifully and violently illustrated by the life cycle of stars, the very engines of creation. When a massive star exhausts its nuclear fuel, its core collapses in upon itself in a matter of seconds, resulting in a supernova explosion of almost unimaginable power. For a brief moment, this single star can outshine its entire host galaxy, a brilliant funeral pyre that marks not an end, but a spectacular, generative beginning. In the incredible heat and pressure of this detonation, something miraculous occurs. The very elements that make our world and our bodies possible are forged. Every atom of oxygen we breathe, the iron in our blood, the calcium in our bones, and the silicon in the rocks beneath our feet, all were created in the heart of a dying star and scattered across the interstellar medium by its violent death. This stellar sacrifice is the ultimate act of cosmic recycling, where the death of one celestial object provides the essential, enriched ingredients for the birth of new stars, new planets, and ultimately, new life. This process of renewal extends far beyond individual stars, governing the largest structures in the universe. Galaxies themselves are engaged in a continuous cycle of interaction, merger, and rebirth. When two galaxies collide, it is not a simple act of destruction. It is a creative cataclysm. Their gravitational embrace, which unfolds over hundreds of millions of years, shreds their beautiful spiral structures, flinging out vast tidal tails of gas and stars. Yet from this chaos comes an extraordinary burst of new creation. The immense compression of gas clouds during the merger triggers a ferocious wave of new star formation, a starburst that lights up the galactic wreckage with the blue-white fire of millions of newborn suns. The old galaxies are consumed, but from their material a new, often larger, galaxy is formed. This galactic cannibalism is a form of cosmic metabolism, breaking down old structures to fuel the creation of new, more complex ones, ensuring that galaxies evolve and adapt over billions of years. On the very largest scale, some cosmological theories suggest that the entire universe might be subject to its own cycle of renewal. The prevailing model points to an eternal expansion, a long, slow exhalation driven by dark energy leading to an eventual heat death. But an alternative, cyclical model exists, the concept of a big bounce. This idea proposes that the expansion of our universe could one day halt, reverse, and culminate in a cataclysmic big crunch, where all matter and energy collapse back into a state of incredible density. Rather than being a final end, this collapse could trigger a new Big Bang, birthing a new universe from the ashes of the old. In this breathtaking scenario, our entire cosmos is but one iteration in an infinite cycle of universal death and rebirth, each cycle potentially giving rise to new physical laws and new forms of complexity. Whether this specific model is true, the concept powerfully mirrors the cyclical patterns we see throughout nature. This pervasive theme of renewal is a fundamental characteristic of all living systems. In a forest ecosystem, a fallen tree does not represent waste. It becomes a nurse log. As it decays, it returns vital nutrients to the soil, creating a rich patch of earth that nourishes the next generation of seedlings. The death of the tree is what makes the forest thrive. Our own bodies are in a constant state of renewal, with cells dying and being replaced every moment, our very physical form being entirely remade over the course of years. The universe operates on this same principle, but on a scale so grand it is almost beyond comprehension. A supernova is the universe's ultimate nurse log. A galactic merger is its way of rejuvenating itself. The cosmos understands that for there to be creation, there must first be destruction. For there to be new beginnings, there must be endings. This dynamic balance between dissolution and generation is not a sign of a chaotic or indifferent universe, but rather the signature of a system that is vibrantly, powerfully alive, a system that is constantly innovating, adapting, and finding new ways to express its infinite potential. In the grand tapestry of existence, every ending is woven into the beginning of something new, reminding us that we are part of an eternal, regenerative process that transforms stardust into galaxies, planets, and life. So where does this incredible journey leave us? After exploring 35 distinct phenomena, from the rhythmic breathing of galaxies to the silent, musical harmonies of orbital resonances, a profound and unifying pattern emerges, one that challenges the very foundation of how we see reality. We began by reimagining the universe not as a cold, empty void, but as a living, breathing entity. And at every turn from the quantum scale to the cosmic web, the evidence has mounted, revealing a cosmos that is anything but inert. It is a system that pulses with galactic heartbeats, communicates through quantum entanglement and gravitational waves, grows and metabolizes through stellar fusion and black hole digestion, remembers information in holographic storage, and may even possess a form of consciousness through which it observes itself. These are not isolated, metaphorical curiosities. They are interlocking pieces of a grand puzzle, each one providing a different perspective on the same breathtaking conclusion. The universe behaves in ways that are astonishingly, undeniably lifelike. This is not to say the universe is a biological organism in the way a starfish or a sequoia tree is. It operates on a vastly different scale and with a different set of rules. But the parallels are too deep, too consistent, and too functionally similar to dismiss as mere coincidence. We see the same principles of self-organization, feedback loops, and cyclical renewal at work. A star's life cycle of birth, death, and material recycling mirrors the nutrient cycles in a forest ecosystem. A galaxy's merger with another, absorbing its resources to fuel new star formation, is a form of cosmic metabolism. The universe's constants are fine-tuned with a precision that suggests not random chance, but a fundamental bias toward the emergence of complexity and awareness. When we step back and look at the whole tapestry, the individual threads weave together into a picture of a single, dynamic, and integrated whole, a universe that is actively managing, regulating, and evolving itself. This unified vision fundamentally transforms our understanding of our own place within this vast whole. For centuries, the scientific narrative often placed humanity as an accidental byproduct, a tiny, conscious speck on a lonely rock in an indifferent and mechanical cosmos. But this new perspective turns that story on its head. We are not separate observers looking at an external universe from the outside. We are participants, integral components of this living cosmos. The atoms that form our bodies were forged in the hearts of long-dead stars, scattered across space by supernovae, and gathered together on a planet whose magnetosphere breathes in rhythm with its sun. Our consciousness may not be a ghost in the machine, but rather the universe's own capacity for awareness becoming localized and individual. Our drive to explore, to understand, and to create is not a human anomaly. It is the universe expressing its innate curiosity about itself. We are how the cosmos knows itself. This shift in perspective from separation to participation is perhaps the most significant outcome of this exploration. It bridges the traditional gap between science and spirituality, not through mysticism, but through a deeper reading of the empirical evidence. It offers a new story, one that is both scientifically rigorous and deeply meaningful. It's a story that invites awe and reverence, not as a rejection of reason, but as its fulfillment. To see the universe as a living entity changes our relationship with it. We are not owners or conquerors of nature, but stewards and conscious participants in a grand cosmic process. This vision calls for a new ethic, one of responsibility and profound connection, where caring for our planet and each other is understood as caring for a small, but vital, part of a much larger, sentient whole. It is an invitation to live with a sense of wonder, to look up at the night sky and feel not small and alone, but deeply, fundamentally connected to the vibrant, breathing, thinking universe of which we are all a part. As we conclude this extraordinary journey through 35 phenomena that reshape our understanding of reality, it's clear that the universe is far more mysterious, interconnected, and vibrantly alive than we often assume. We began by reimagining the cosmos not as a cold, empty void, but as a dynamic, conscious entity, and at every scale, from the quantum flutter of particles to the gravitational dance of galaxies, we found evidence that breathes life into this idea. We've seen galaxies pulse with rhythm, stars metabolize energy, black holes regulate growth, and quantum particles communicate instantaneously across vast distances. We've witnessed how the universe builds with fractal patterns, remembers information, and renews itself through cycles of death and rebirth. Each phenomenon on its own invites wonder, but together they form a mosaic of meaning that challenges us to see the cosmos not as a passive stage, but as an active, participatory presence, a partner in existence brimming with beauty, rhythm, and purpose. This perspective transforms our relationship with the universe. We are no longer mere observers, separate and insignificant, peering out at a foreign and indifferent cosmos. Instead, we are intimate participants in a grand, unfolding story, the universe becoming aware of itself through us. Every time we gaze at the stars, every time we unravel a cosmic mystery, we are not just studying the universe, we are the universe studying itself. This realization invites a profound shift in consciousness, from feeling like isolated spectators to embracing our role as conscious agents within a living, breathing whole. It bridges the gap between science and spirit, not through dogma, but through a shared sense of awe, a recognition that the drive to explore, to understand, and to connect is woven into the very fabric of reality. So, what does this mean for you? How does this vision change the way you see your place in the cosmos? Perhaps it invites a deeper sense of belonging, a feeling of being at home in a universe that is not cold and empty, but warm with possibility. Maybe it inspires a new ethic of care for our planet, for each other, and for the cosmic processes that gave us life. Or it might simply fill you with a renewed sense of wonder, a childlike curiosity to look up at the night sky and feel the pulse of a living universe. We encourage you to sit with these questions, to reflect on how this perspective reshapes your view of reality, and to share your thoughts and insights in the comments below. This is just the beginning of a much larger conversation. If this journey has ignited your curiosity, make sure to subscribe and hit the notification bell so you never miss our next deep dive into the mysteries of space, time, and consciousness. From the enigmas of dark matter to the frontiers of multiverse theory, there are endless wonders left to explore. Thank you for joining us on this adventure. Until next time, keep looking up with wonder, keep questioning with courage, and remember the living cosmos isn't just out there waiting. It's within you, around you, and forever inviting you to become